What's going on there? No.
Gabi, betelo mo
Yeah.
beta video
Eh, naza na zoom déjà. Naza na zoom, natindela ye ka zoom, ayoka soki.
Okay, bima banda zana mo liposi. Baluba oyo.
Ah, na atinde. What's up, man? Man, I'm so blessed.
Gibbs?
Yes, can you hear me?
Gabby?
Yes, can you hear me?
Not yet.
Can
Gibbs?
you hear me?
Fais-moi zoom, David.
Can you hear me? Ah ouais? Can you hear me? Martin? Martin? Can you hear me?
Gabby?
Can you hear me?
Gabby?
Ah ouais? Can you hear me?
Speak
ouais?
again?
Can you hear me?
Yes, I can hear you. Can you hear me?
Oh, okay, okay. Is it good, the sound?
Hey, can you hear me?
I can hear you properly.
Okay, cool, sure.
Thanks so much, sir.
Cool, bye. Hey, Gabby?
One, two, 1 million, 2 million, 3 million, 1, 2. One, two, 1, 2. 1 million, 2 million, 3 million. 1, 2, 1, 2, 1, 2, 1, 2, 3, 4, 5, 6, 7.
You have to close it or?
For now, yeah. You just
Hello, Brad. Good morning. Can you hear me?
Good morning, Samaya. Yes, I can
Oh,
hear you.
great. And can you hear the music as well?
It's very soothing. Yes, thank you.
Yes. I'm sorry it's so early for you, and thanks so much for doing this.
That's quite all right. Looking forward to
Great.
seeing you
Yep.
all.
Oh, there you are. You're on screen. Thank
Uh-oh.
you.
Hope I'm not too large.
Lovely to see you. Thanks, Brad. And for the panel discussion, I'd like you also to participate if you can,
Oh,
if that's
okay. I didn't
possible.
prepare anything, but I'm happy to opine in when
Yeah.
necessary.
Sure. I'll have somebody monitoring the Zoom, so if you want to put your hand up or anything.
Okay, sounds great.
Okay, great. Perfect. Thank you. Hi, Ryan. Hi, Rob. So you guys will sit there.
I noticed there were a lot more questions this morning, Samaya.
Oh, were there?
Yeah, no, it's good. Yeah. You weren't here last week, were you? Right, okay. I didn't know that the session was going on yesterday. All I know is the invitation. Well, it's hard. Yeah, I mean, I've been to a number of splinter meetings that have had Owen.
Good morning, Nora. Nora? Oh.
Yeah, I can hear you.
Oh,
Hi.
hi, Nora. Thanks so much for
Hi.
making it. I just wanted to make sure you're connected. Thank
Yep.
you. And if you want to raise your hand or anything during the panel discussion, of course, please do. Thanks so much for
Sure.
attending. Thank you. Okay, great. Hi, Paul. Thank you. So you go up there, yes? Yes.
So welcome everyone. This is the fourth session of the working group on the global coordination of ground and space astrophysics. My name is Matthew Collis and I'm standing in for the actual organisers of this meeting, Roger Davies and Rachel Somerville. Rachel unfortunately couldn't make it to the General Assembly, and Roger got an offer he couldn't refuse to go off and look at the SKA site here in South Africa, and so he asked me to stand in for him today. And in fact, I will be taking over from Roger as co-chair with Rachel of this working group for the next triennium. In organising this, Roger and Rachel looked to delegate each of the key sessions to relevant people, and the relevant people in this case were Samaya Sankey and Varun Balero, who have organised this session, which is on the coordination of transient follow-up for LIGO, Virgo, Kagra, and planning for Rubin operations. So I will hand over forthwith to Samaya and let her run this session.
So good morning, everyone, and welcome to the last session of this working group on the global coordination of ground and space-based astrophysics for transients and follow-up. I'm speaking on behalf of myself and Varun Balero, who is online. And we have a very fun-packed session coming up with several talks as well as a panel discussion. There are a few things I'd like to point out. Number one, we're really hoping that we can focus this next hour and a half on discussing the global coordination and what we as an international community, as well as this IAU working group, can sort of work towards moving forward. Secondly, a lot of the recommendations, and we're hoping to build upon a lot of the recommendations that occurred at the first Kavli IAU, this working group workshop that was held actually in Cape Town in February 2020, just before COVID. Many of the panelists as well as speakers were part of this workshop, and the white paper that was co-chaired by Brad Senko is listed there, so please do take a look at that. And thirdly, I'd like to ensure that all our online participants also do, please feel free to raise your hands as well as participate in questions as well as discussion for this community effort. Okay, so without further ado, it's a pleasure to welcome Jenny Driggers, who's the Operations Director for LIGO Labs, who'll be talking about gravitational waves. Thank you.
Hello, so I'm Jenny Driggers. I feel like an interloper because I'm a physicist at an astronomy conference, so thank you for having me. I am the detection lead scientist at the LIGO Hanford Observatory, so I work and am based out of the LIGO Hanford Observatory. I am also the operations division chair for the LIGO Scientific Collaboration. So that involves figuring out when are we going to run our observatories and when are we going to be offline for maintenance. That kind of coordination is kind of one of the relevant pieces that connects with this group. Okay, the most important takeaway, of course, is our sponsors. This material is based on NSF-funded work, so we're always grateful to the National Science Foundation for continuing to fund our work. I'm going to give an extraordinarily brief primer on gravitational wave detection, just in case some folks weren't available last week. There was a whole symposium, but I was not available to join it, so just a quick thing. Black holes, other kind of non-axisymmetric objects move, and that stretches and squishes space-time itself. Today I'm going to focus on known transients, in particular compact binary coalescences, because those are what are most likely to be follow-upable in the near term with other observatories. But please do know that searches are in place for all kinds of gravitational wave sources in our system and in our pipelines. So, okay, space-time stretches and squishes. How are we going to measure it? We use a very basic Michelson-Morley philosophy. We've got 4-kilometer arm cavities, so the distance here is 4 kilometers, and then this delta L that the mirrors move is extraordinarily small. So that's what matters is, in the end, the small amount of change of the mirrors divided by the total length of the baseline of the interferometer. So of course, it's not actually quite so simple as a basic Michelson-Morley from the 1800s. This is a picture of the instrument hall at the LIGO Hanford Observatory, a staircase for scale, and person for scale to kind of get an idea of what we've got. But there is, a laser, there's a main beam splitter. The beams go out, pierce the wall, and the vacuum system goes the full 4 kilometers out, back again, and then we make detections at the output port here. I'm an instrumentalist, so I love the instrument. That's my bread and butter, but of course, once we've actually produced the data, once we've created the instrument and it's detected some data, then we need to figure out how to get astrophysics out of that data. So the data goes to the search groups, and they do things like this where they try and infer from, this example is 150914, our first ever detection, what is the best fit to that? Learning things like, first I'll say, step to this next plot, which is a very similar plot. I don't have enough time to actually talk about all of these details, but the key point is that we made another detection. This one is 190521. But these are the kinds of parameters that we can get out of the data. We can understand the masses of the objects before they collided and became one. We can understand the spins of them. We can also understand the mass after, the spin after, the luminosity distance. Other things like orbital precession, some probability of our having detected higher harmonics, other interesting bits and pieces of information. Okay, so that was meant to kind of connect the instrument to the science that we can do. I'll step back to the instrument for just a moment and show you this very busy plot that I won't talk about at all, because it's clearly much too busy to actually talk about, other than to say it's as a function of frequency, what is the gravitational wave strain that we are sensitive to? So for our current detectors, this is something like the motion of those end mirrors divided by 4 kilometers. And there are many traces on this plot. The key ones to see are the blue trace. That is our total measured sensitivity to gravitational waves. And basically all of the other traces are noise contaminants that are well understood. So the point of this plot is to show that we actually have a pretty good, clear understanding of why our instruments are at the sensitivity and capabilities that they are right now. There is a small unknown region. So the light green that I haven't highlighted with an arrow is the sum of all other noise sources. And the green and the blue match very, very exquisitely at all frequencies except this low frequency region. So that's a target that we work to improve, because it improves our ability to measure heavier objects and also to measure earlier before the coalescence actually happens. We can see something interesting about the events that's about to happen. So we want to improve this region, but also we want to improve kind of all of the other regions. And by knowing our noise sources, we're able to do that. This is also the basis on which we can design future generations of facilities. Since we understand our current facilities, we can say we know what that will translate to for future generation facilities. Oh, right. Reducing noise enables more detections and better detections. This is a very similar plot that I highlight. This is one of my absolute favorite plots. This came out in PRX last September. One of the things that we did for our current observing run is we made our quantum squeezer even better. So this is, again, as a function of frequency, how sensitive are we, gravitational wave characteristic strain. The black curve is if we only use kind of classical mechanics, classical light is a wave, boring, old school. For our third observing run, which completed in 2020, we had a quantum squeezer that would improve the phase noise of the detector at high frequency at the cost of hurting the noise at low frequency. So we can run the quantum squeezer in that mode now and see what the effect would have been. So then if we turn on our quantum squeezer without the new technology that we've just built, then we go from the black classical trace to this green trace. And you can see that there's an enormous amount of contamination at these low frequencies. We've made enough improvements in the amount of quantum squeezing that we're doing, and also other noise sources, that we can no longer use a plain old squeezer. I use air quotes because obviously squeezing is pretty fancy-pantsy. So now we take that quantum squeezed light and we reflect it off of a 300-meter cavity, and that allows us to rotate the quadrature of the squeezed light. That allows us to manipulate, as a function of frequency, the squeezed light, so that in the end we get this big factor of 2 improvement at high frequency in the purple trace, but we don't contaminate at the low frequencies. So this is, the purple trace is taking our classical noise curve, injecting the squeezing, but with the new technology that we've implemented for the 4th observing run. And we get this really exquisite factor of 2 improvement without contamination at low frequencies. So this is a very much enabling technology. It's also kind of nifty because this is actually, I'm pretty sure, one of the only places on the planet where we actually use quantum mechanics to improve a physics measurement. There are some like new exciting things in biophysics where they're starting to do that kind of work, but there are very few places where we actually use quantum mechanics to improve something, and this is giving us a huge improvement in our ability to do astrophysics. Okay, so why is that important? Why is reducing the noise important? We measure amplitude, so we're directly sensitive to distance out into the universe. So every factor of 2 sensitivity improvement leads to a 2 times distance out to which we can observe, which volumetrically is an 8 times increase in the volume of universe to which we are sensitive, which could lead to up to something like an 8 times increase in our detection rate. So this plot is just to show, and you can see that I've blanked out a lot of it that we'll see in a couple of slides, taking that noise curve that we saw on the last few slides and translating to what does it mean in terms of source frame mass of the objects, the progenitor objects, and redshift, how far out can we see? And this is for a canonical signal to noise ratio of 8. But you can see that we're quite sensitive, particularly to black holes. Out to redshift of maybe a few is kind of the cutting edge of what we can do with our current generation detectors once we achieve this A+ design sensitivity, which we are not currently at. So this is something we hope to get to in the next kind of 3 to 5 years. Connecting back to why bother, the point is, of course, that we would love to be able to see something from objects that are likely to emit other kinds of matter, emit other kinds of astroparticles that are interesting and easy to see something with. So in particular, the highlight of this, so this is from, oh dear, I don't have a reference for it. Anyway, this is from GW 170817, the one gold-plated neutron star collision that we've seen that was followed up by a huge sector of the astronomy community. And the thing to point out is that, you know, we're able to do an okay job localizing where things are, but it's not very precise on the scale of the telescopes that you folks have. So that's an area that we're trying to work on. As we improve our sensitivity, we can see things with better signal to noise, we can get more exquisite localizations. Oh, I'm in trouble, time-wise. Okay, just to connect, GW 170817 was over the skies of Madagascar when it was detected. Unfortunately, the telescopes here in South Africa, my understanding, it was cloudy that night. So we can observe day and night 24/7, but not all telescopes are able to do that. Okay, I'm gonna have to start skipping plots, for which I really apologize. I'm happy to give folks copies of these slides. Improving that low frequency sensitivity directly leads to improvements in our ability to issue pre-merger alerts, to say, we've accumulated enough confidence that something is about to collide, that it is worthy of telescopes slewing to go look at that piece of the sky. So as we go forward from our current generation, our best possible capability, if it took no time processing the data, which it takes time processing the data. Right now we have, like, at maximum something on the order of 20 seconds before merger is the most optimal case of the most perfect, beautiful coalescence. But as we achieve our design sensitivity, that should be something on the order of 100 seconds. So that's the reason that we're working towards this low frequency improvement, is because we'd like to obviously give further time for early warnings. I won't read to you these times again because I'm out of time. The point is that we issue our first preliminary notice about 20 to 60 seconds after the merger time of a coalescence, which is a great improvement over what we've been able to do in the past. And then we've got human vetting within about an hour, but all of the machine readable information is out within 20 to 60 seconds. This is just a pretty plot of all of the cumulative detections that we've made over the last several years. So I've excised the times between observing runs and just stitched together the times. And you can see, well, it's hard to see unless I draw a line on it, that our rate has increased quite significantly. I'm also delighted to say I had to update this plot from when I made my first drafts to this version because we got 2 gravitational wave candidates, not last night, but the night before. So that's always fun. We now get them about 3 times a week. This is a copy of our observing plan, which you're welcome to find here at observingdocs.ligo.org. And it shows our past what we've been able to do, and also with some amount of uncertainty, what we hope to do in the future. And some of you may be aware, if you closely follow our alerts, that we're offline right now for one of the LIGO detectors. And this update plan, we post something about once a month, information on we had some damage inside the vacuum system. So this is just a photo of that removed optic right before it was replaced. Clearly, if we want pristine laser beams going through optics, we can't have craters in those optics. So we had to pull this. And it takes about 3 weeks. So the repairs are complete. It takes about 3 weeks to pump down to ultra high vacuum for us to begin observations again. So I'm hopeful, let's see, August 19th is the very earliest possible date, depending on our vacuum pressures, that we can start working towards observing again. This is a different way of looking. This is a Jenny version of those timelines for existing facilities. So this is kind of taken off of that observing docks plan. But then also overlaying it with LIGO India, which is coming online in the near future. So this is a copy of the LIGO technologies placed in India to improve our localization abilities. And then Cosmic Explorer, which is our next generation vision in the United States for what a next generation facility should look like. And Einstein Telescope's timeline is quite similar. Now I have run out of time. So I will flash to you that the Cosmic Explorer group is trying to do science right. We can engineer our way out of a lot of challenges. We cannot engineer our way out of being jerks and bad humans. So that's a key focus of the Cosmic Explorer project, is to make sure that we're doing science responsibly and right. This is that plot again. So as we go from current generation detectors all the way to future generation detectors worth of sensitivity, what we think we can achieve in terms of source frame mass and redshift. And Cosmic Explorer and Einstein Telescope here are called that because they really should reach the farthest reaches of the universe. I'll just flash this plot, but not talk about it much, that the LISA and space-based projects are very complementary to the ground-based detectors. They are not like replacements for, they're very complementary. So we look forward to LISA being online. My understanding from yesterday or 2 days ago was that they anticipate launching in 2035. And then there are also some candidate space-based projects that could fill in this gap on a shorter timeline than this green curve. The point of Cosmic Explorer and our next generation vision in the United States is that it is entirely science-driven. So we'll take our known technologies and abilities and then look at the kinds of things that we want to explore in the universe and make sure the design of our facility enables that astrophysics. And because I'm way over time, I'll invite you to look at the Cosmic Explorer Horizon study for more details on those. So just briefly, kind of in conclusion, we're really excited about Cosmic Explorer and the future facilities that we've got. But I do invite folks to follow along with our current alerts. This user guide has instructions on how to ingest our alerts. And then all of our data is on the Open Science Center. So thank you.
Thank you so much, Jenny, for that excellent talk. I'd like to invite the floor in the room as well as online to ask any questions for Jenny. If there are any immediate questions, please. Yes, and if people can also identify themselves. Thank you. So, Stefan.
Okay, Stefan Wagner, Germany. Quick question on your noise spectrum. How variable is that in time? I'm not talking so much about the specific peaks that you have, but the flow that you talked about, in particular at the lower frequencies. Is that something where your actual level varies? And if so, on what timescales?
How much it varies is overall quite little. It's not very noticeable if you look. So just sitting in the control room, we have that spectrum update about once per second, just so we can be monitoring it live. Most of the variability is not noticeable just to kind of the human eye when looking at that once per second spectral update. We do have an entire team of data characterization and data quality folks who have automated checks. One of our biggest sources of variable noise is if some scattered photons exit the main beam, hit something like the vacuum tube, and at just the wrong angle, and then are able to pick up vibrations of the vacuum tube and then scatter back into the main beam. That adds phase noise. That can be on kind of a 20 hertz scale. So relatively slowish low frequency for us. That's a low frequency contamination. And that really depends on things like the train at the end station at the Louisiana detector is something like 1 kilometer away from the end building, or it could depend on wind conditions at the Hanford site. We're very windy. Anyhow, I'm happy to talk more about it, but it's not that egregious, and it's certainly something that we work on eliminating as much as possible in the detector, even before we get to post-processing data cleaning.
Thank you, Ryan.
It's good to see that that optical will be replaced soon in the detector. I was wondering if there's a better understanding of the cause of the problem in the first place.
No, that's a really important question, and we don't actually understand why that optic was damaged, which is unfortunate. We don't know why it was working for a year, from May 2023 until April 20-something or other this year. We didn't know what it was. We knew it was bad, so we steered the main beam a few millimeters to the side in yaw. And then right around the 4th of July, terribly inconvenient in the United States because it was a long weekend, the second incident happened and we blew the second crater, at which time we decided that we really needed to go in because we didn't know. We had a candidate list of 6 different optical elements that could have been damaged in some way. And we didn't know what happened until we actually broke vacuum and looked with our eyes. We've packaged those damaged elements up. They're down at Caltech now for forensics. We take FTIR samples also to see if there was any contaminant, so JPL analyzes those for us, but that takes several weeks to get any information back from the JPL FTIR analysis. So, hot topic, and I don't have an answer.
Brian.
Brian Schmidt from Australia. What do you need to get good positions if you were to have the 2 next generation Cosmic Explorer and Einsteins? You still need a 3rd leg. Now, presumably, ideally, you'd have a 3rd one of those, but you might be able to get away with a little less as the 3rd arm for positions.
When you say positions, do you mean localization in the sky? Absolutely, and that's something that Vicky Caligara's National Science Foundation Blue Ribbon Panel, so the National Science Foundation commissioned a Blue Ribbon Panel to look at the United States next generation facilities projects. Cosmic Explorer was the only one in the United States to submit a proposal, but Vicky's group looked very carefully at this. Cosmic Explorer would like to have 2 legs, 2 L-shaped interferometers in the US, but we know that the Einstein telescope in Europe is also progressing very well. So Vicky's group looked, and that with even just 1 in the US, 1 in Europe, because that's well separated, and then a current generation length, but fully upgraded to what we're calling our 6th observing run. So that 6th observing run should start in kind of the maybe early 2030s. With the 3rd leg, the 3rd interferometer being that extraordinarily upgraded version of a current generation detector, if that 3rd leg is somewhere far separated, for example, India, where we are currently constructing such an observatory, that can get us awfully close. Another thing that would be truly phenomenal is, I'm sure you know that Osgrav and lots of Australian collaborators work very, very close on the technology development for both current generation detectors and future generation detectors. And so while these are quite expensive on at least our NSF budget type scale, it would be truly phenomenal if we could also have one in Australia. So I would be really delighted if that was something that...
And they're astronomically expensive by Australian scale.
Yeah, these are $1 billion US dollar class observatories for the future generation. So that's a little expensive.
Thank you. Richard, are there any online questions? Okay,
you.
we'll end here, and thanks, Jenny, for a great talk. And then it's a pleasure to welcome Federica Bianco from the University of Delaware, as well as the Deputy Project Scientist for the Rubin Observatory.
Thank you. Hello, everybody. So I'm going to talk about ground-based follow-up of GW alerts. I know that you had a lot of talks about amazing facilities yesterday, so I'm kind of going to focus on how we're going to get those to work together to actually detect the optical counterparts. So just very briefly, what can we learn if we detect the optical counterpart of a gravitational wave event? We can test GR, we can see if the speed of gravity is equal to the speed of light, the equivalent principle. We can test Lorentz invariance, of course, a lot of other things that I'm not mentioning. We learn a lot about stellar physics. I'm not mentioning everything here, just the local coalescence rate of binary neutron stars is the one that I'm mentioning. We had a great plenary talk here that showed that maybe we need to revise our expectations for neutron star mergers rates. We can also learn, if we get GRBs, we can also learn a lot about GRB physics, etc. We can learn a lot about cosmology, and that's really exciting. We have a different probe that suffers from different biases, so we may be able to break the degeneracy between astrophysical and microwave probes of cosmology and measure the Hubble constant in a whole new different way. Of course, we only have one optical counterpart of a gravitational wave event so far, so we can't do that with one event. We need many more, so we need to turn those GWs into ATs or astrophysical transients to be able to do this. So we do have one. I know you heard a lot about 170817 yesterday, but again, here it is. GW 170817 was turned into AT 2017 GFO. AT stands for astrophysical transients, indicating that we have detected an electromagnetic counterpart. This is the location of the gravitational wave event on the sky, and of course, these are plots from the Abbott paper that came out right after the astrophysical transient detection. Here we have the astrophysical counterpart of GW170817. Fine, that's all well and good. The process of detecting this astrophysical counterpart is really an exemplary work on coordination and collaboration worldwide to achieve a scientific goal that was really promising and made us all think that we're going to find these things by the bucket. That did not happen, of course. So this is a plot from the multi-messenger paper on 1717, again, about 17. And so at the top, you see the gravitational wave counterpart. And then you see all the facilities that picked up observations. And you see in those vertical lines when they started observing and followed the trigger by LIGO Virgo. And in particular, you see the optical. I'm here to talk to you about the optical side. So these are all the facilities that looked in the optical wavelength, mostly from the ground, that looked at the sky and tried to detect the event. And this is really a very large number of international facilities, observatories of all sizes, all modes of operations. The bottom plots that show the astrophysical images show the first facilities that reported the detection. Of those, only one was doing a blind area survey on the sky region that GW170817 was localized on. All the other ones were doing surveys that were targeted to galaxies that would be likely hosts. So you have an estimation of the distance of the event, and then you can target specific galaxies. That helps you because, as Jenny said, we have a large localization area compared to the sky area that most facilities can rapidly survey. And rapidly is the key word here. We really want to get on these transients within the night. In a day or two, the transients altogether, the optical transients are expected to last order of a week or two, but really a lot of physics we learn at the beginning in the rise, in the electromagnetic rise of the transient. That really has a lot of hints about the chemical composition of the transient, the R processes, etc. So in order to maximize our ability to cover the sky area, we typically do these searches that are targeted to galaxies that might be host. There is a risk, of course, there, especially as we put these objects further away into the universe, that we might miss galaxies that are just there, and we don't know that they're there. So blind area searches are a great idea. You can only do them if you have a large field of view telescope. DECAM is a survey telescope, so it does have a large field of view. We'll do better in about a year on that front. So there's an automation problem that it requires to be solved in order to enable this kind of work. I'm going to claim that this is actually basically a solved problem. There's a lot of great people that are working on all the aspects of this. We need to get an automated broadcast of the GW event. LIGO does it, no problem. We have Shima and the astrophysical telegrams that can broadcast it to the facilities. The facilities can pick it up. We have automated tools. In fact, I have a much more fun animation of what I'm saying. So we have the discovery engine. I put LSST here because it will work as a discovery engine, as I'll show you in a minute. But at this point of the talk, think primarily of LIGO Virgo Kagra. We have ways of dispatching these alerts. This is a plot of a software called a broker. These are astrophysical softwares that have been built really in the last decade, primarily thinking about Rubin and the alerts that Rubin will broadcast. How do we follow them up? The brokers pick up the alert, augment it, classify, select it. And they can be used for all discovery engines, and they're already being in use for ZTF. We then have automation of follow-up. We have target of observation managers that turn the GW localization area into this is what you should observe given the telescope time that you have and the telescopes that you're going to use. We have automation of triggers at telescope through Aeon and other systems, and those work even on large facilities like Gemini. So I'm going to claim that the automation of the discovery chain of astrophysics is not the bottleneck of successful gravitational wave follow-up. It's a difficult problem, but a lot of incredibly talented people have been working on this, and this infrastructural issue is not something that worries me at all at this point. So why was GW1708-17 such a success? Well, a couple of key elements that really pertain to the nature of this transient. Particularly, the localization area was 28 square degrees. That's not that bad. Your typical telescope has order of arc minute, field of view, large telescope, order of degrees, 28, we can cover that. It was also a very nearby event, so a very bright astrophysical transient that was detectable with relatively small telescopes. So that's the initial localization area, and then it shrunk even further. So the final localization area is that tiny area of sky. And this is like, I don't know if you saw it, like it stays on the map, right? So this is how it compares to most of the other detections in O2. Of course, those areas are shrinking, but based on the characteristics with advancements in technology from the LIGO Virgo Kagra systems, but based on the characteristics of the object, we were very lucky with that one. Okay, let's take another example, GW190425, the only other certified binary neutron star trigger that we had for which we did not find an astrophysical counterpart. So what was the bottleneck? Well, the nature of the transient. This is a much further away transient, estimated 520 million light years away from the gravitational wave signal. And the localization area on the sky was significantly larger. The 50% localization is 1,300 square degrees, and the 90% localization area, that's typically what you would like to cover, is 7,400 square degrees, so pretty massive. So we need a massive amount of coordination to cover this area and hope to discover the optical counterparts. So there's a brilliant paper by Kanan and Arkavi that came out recently this year that really looked in detail at this event and what happened in the follow-up campaigns, whether that was the optimal strategy that was implemented broadly, or could have been improved, and what was the probability that we would have actually detected the counterpart of this GW if we had a better strategy for follow-up. So on the left, you see the localization map. Of course, this is the initial one, and then it evolved. It actually shrunk in the updated localization. The actual published localization is a little bit closer to the initial one. On the right side, you have the area of sky covered by telescope, by optical telescopes from the ground. Actually, I think that might also include space telescopes like Swift. But most of that footprint is ground-based observations. And it looks really good on paper, but maybe not so good. So there's a really important organization, software, both API, the treasure map, which is trying to coordinate observations, follow-up observations of gravitational waves. And not only it's helping coordinate them, but the way in which it's doing that is by connecting communities, essentially, and making an API available that allows you to see what everybody else is observing, and to submit what you plan to observe and what you have observed, so that we can really reach a global coordination. And also it stores the data. So the study that Kenan and Arkavi did is based on the data that was collected by the treasure map on GW19, I forget the number. Okay, so it shows you the sky map with the localization area. This is a different GW just because it presents a little bit better on the screen. You can submit your observations. You can look at what other people are observing. And here is a list of all the facilities that have reported observations for GW follow-up over time on the treasure map. And some of them, you can't read them, I can't read them either. Some of them have submitted thousands of observations. It goes down to facilities that have submitted 10, 20, 30 observations overall. I'm going to point out a few of them that are frequent users of the treasure map and show the international nature really of these collaborations. GoTo is at La Palma. It's a telescope designed for following up gravitational waves. It is itself a UK, but also international collaboration. Of course, we have facilities like Mirror Lake, which is part of Black Gem. That's an international collaboration that I don't need to introduce. In this venue, we have the 7-dimensional telescope. It's just an example of facilities that are rising in Asia. This is a Korean facility. And altogether, on the treasure map, I found 35 facilities that have reported observations from the US, South Africa, UK, Australia, Korea, Israel, Canada, Japan. There's probably more places, facilities that I couldn't understand the name of, and I couldn't figure out what the facility actually was because of the way in which it was reported. So really, the point that I'm trying to make is that the follow-up of gravitational wave is necessarily and very naturally an international collaborative process. Okay, let me go back. Oh, and I'm not going to talk about this, but also if you then include, if you broaden MMA outside of GW and you think about neutrinos, even more international participation, and yeah. Let me go back to where we were. So let me go back to GW 1904-25. So on the treasure map, you can make these pretty plots that show what is the area of sky that has been covered as a function of time. You don't see the time axis here, but this includes the first 3 days of observations. 75% of the sky was visible weather-wise on the night of the trigger, and over 95 would have been visible within the first 3 days. And this is the probability area, the cumulative probability area that was surveyed, and the cumulative sky area that was surveyed by any facility, if you add up all the observations that were taken at any depth. And this is just in the optical. This is what happens if I drop to magnitude 21. Some of those facilities only can access very bright magnitudes. They prioritize maybe field of view over depth. So the sky area cover shrinks. And if I go down to magnitude 24, there's nothing there. Okay, we can solve that problem. But before I get to solving that problem, so the point that they make in this paper, which is really quite brilliant, let me just go straight to the word, is that 90% of the region that basically all of the 90% probability region for this event was available to be observed. And it would have been observed if there was better coordination. But what happened is that the high probability regions of that map, the center of the 90% localization area, was observed by everybody over 100 times. And the 50, the areas further out were progressively more and more neglected. So they argue that we could have detected a gravitational wave counterpart based on most models for optical counterparts of GW if we had a better coordination and covered the entire footprint. This is a really important point. Okay, I know that I'm going to run long on this talk, so just give me a couple of minutes. So the bottleneck of turning GWs into ATs really is cooperation. It's a sociological problem, not an infrastructural or an astrophysical problem. We just need to get better at collaborating, which is difficult because everybody wants to be the group that has detected, ideally got the first detection of the astrophysical transient. How do we share credit? How do we share data? How do we protect junior people in this more open data, open sharing world? Okay. Part of the solution will come from Rubin Observatory. I'm not just saying that because I'm deputy project scientist. But Rubin was designed for something completely different. It was designed to conduct a survey. So we weren't thinking that would be responsive to anything when we were conceptualizing the survey. But it became more and more obvious that Rubin is built as an excellent TO target of opportunity machine for gravitational waves, because we combine an incredibly large field of view, nearly 10 square degrees, with a significant depth. On our standard exposure time, we get down to magnitude 24 in R, with a high resolution of 0.2 arc seconds per pixels. Of course, we're going to be seeing limited on that. So so this is how we cover a 19 square degrees area. This is how we will cover an 5 square degrees area. So we can be very rapid at following up the entire localization area. Okay. A lot of papers recommended that we consider enabling a TO program with Rubin because of what I just said. Pioneering paper was Margutti et al. 2018. That's a white paper that was turned into a peer-reviewed paper as Andreoni et al. 2021. And we heard the community and we thought they had a good idea. And so we are enabling a lot more papers. We are enabling a TO program. The time allocated at the Rubin Observatory is, the survey strategy, so essentially the allocation of time for different pieces of the survey, is conducted by the Survey Cadence Optimization Committee, which I chair as deputy project scientist. And in our phase 2 recommendation last year, we recommended that the TO program is in fact enabled on Rubin Observatory for up to 2 to 3% of the LSST time. That doesn't sound like a lot, but LSST is observing for 10 years. So that ends up being a fair amount of time. We also recommended that we get the community to tell us how to spend that time best. So we organized a meeting last March. We had 114 community members, 42% in person, the rest remote. It was a fully hybrid meeting with staggered working times for different time zones so that we could be supporting an international community interested in this. We looked at gravitational wave, neutrinos, and also solar system TOs. And we designed a plan that will spend about 298 hours over the survey on gravitational wave follow-up, and about 6 to 18 hours on neutrino follow-up, and some time on solar system that y'all don't care about. We simulated what would happen. This is a simulation of how we would respond to hypothetical triggers in 05. So we can cover this area of sky over roughly a year and a half of 05 operations. We would have a special survey cadence for lens binary neutron stars as a special case of particular interest if we get triggers of that nature. We would follow neutrinos. We can follow neutrinos with a single pointing, easy, because it's a 10 square degree field of view. So we expect to start following neutrinos at the beginning of operation, which, by the way, you probably want to know when Rubin will start observing. I have a T-shirt. My T-shirt says 2024. T-1. So we are really gearing up to start the survey. The survey is expected to start at the end of 2025. We're going to start commissioning this month. And for the purpose of this presentation, we're going to start observing well before the beginning of 05, and we'll run through 05. Fine. One thing that is important, I'm leading to a wrap-up, is that LSST has a complicated data rights system, but the primary data from which you would do gravitational wave counterpart searches are actually world public. So we broadcast all of the transients that we see in our observations within 60 seconds of shutter close. We broadcast them through the brokers that I mentioned earlier, and that is a world public data product. What you get with those data are the IA sources record that trigger the alert, the difference image analysis object, you get 12 months of force source photometry, and you get cutouts, so the cutout images of template, science, and difference image. There's additional data products that are useful for this that are only accessible to data right holders. There's reprocessed time domain data in 24 hours, and then the images become available 80 hours, at an 80 hours delay due to security concerns and embargoes, but those are data right holders, data products. Fine. So we expect to get about 200,000 alerts in the data that we will collect in one night of a follow-up of a binary neutron star typical event. So that's a lot, right? So generally we expect to broadcast 10 million alerts per night. So the problem is going to be, what do we do with these alerts? How do we turn them into detections, and how do we identify what is the counterpart? And I don't have any more time, but I have one slide on this. So something that I want to point out, it's work that I had done kind of in reverse in 2018. And OFEC, there's a great paper by OFEC in 2023, maybe even 2024 about this. Of course, we're going to need spectroscopic follow-up of DATs to actually identify what they are and to study the physics of the transient. But to detect them, to understand which one is the counterpart, photometry goes a long way, particularly if we have time series of the transients. Because in a space of color versus time evolution, these transients are very characteristic. They distinguish themselves from most other transients. The plots are a bit complicated, so maybe just take my word for it, but the background are common stars, common supernovae, simulations on the left, real data on the right by OFEC 23. And then the streaks that you see is the evolutionary curve of a kilonova simulated on the left, and on the right is 170817. So these objects, if we have time series, they do separate themselves from known objects and known kilonovae in a photometric space. I think that's most of what I had to do. If we do that, then we can make the most of the really large facilities that we will need for spectroscopic follow-up. And my conclusions are that we have an infrastructural challenge that is very hard, but also solved. We have a sociological challenge that is harder and not solved.
Thanks very much, Federica, for that excellent and thought-provoking talk. Some of those points will be discussed hopefully in the panel discussion, but I can see already a couple of questions. Rob, please go ahead.
Rob Fender, UK. Thanks for the talk. It was very interesting. On your slide, which obviously you can't go back to now, about the software infrastructure being a solved problem, I completely agree. And in fact, I think that problem was solved 20 years ago. I mean, people look back at, I recommend people look back at the E-Star project, which was developed by Alistair Allen and others. And I think the problem has always been political and administrative, and you need observatory directors to agree that their telescope can be robotically taken over by a transient alert. That's always been the problem. It's never been really a software problem, I think. I mean, we have a new generation of software now, but this was a solved problem, I think, 20 years ago. It's human beings. So I completely agree with you that that's the issue.
Yeah, I agree. And, you know, I obviously don't have the space or the time to mention all the progress over time on this. The most recent developments are really the TOM, the Sky Portal, the Aeon, and they're the softwares that we use today. But yeah, it's a difficult problem. There's great software engineers that are working on this. I don't want to diminish their work being like, it's a solved problem, but it was very hard, but it's done.
Thank you. One further question.
Yeah, hi. Wonderful talk. I'm Utkarsh Pathak from IIT Bombay, India. Since we talked about GW190425 a couple of times for that particular paper, I have two comments. One being the larger collaborations which do use treasure map, ideally I would want them to also send out GCN, which is the saying pointing where they are pointing at,
Yes.
so that the other collaborations of even smaller telescopes can take a look and not do the same. And one more thing that the paper did not really take into account is multiple observations of the same tile.
Yeah.
We need different filters or maybe the same filter but at different times.
Yeah.
So those kind of things will change the result a little bit.
Absolutely. I mean, I have argued implicitly that we need at least 2 filter observations to get color versus rate of change. So to your second point, absolutely. Yes, it's true we covered the same area 100 times. Not all of them were covered in G-band, so it's not entirely 100 redundant observations, and they were taken at different times, so we still can build evolutionary tracks from those co-added observations. And for the publishing of pointings, yes, publishing your observing plan is really important. That will be public for Rubin. Also will cover the whole footprint of these events, so maybe that's a little bit less fundamental that we do that. But others should publish their plans as well.
So I think, Paul, maybe we can leave the question to the discussion session, and we'll move on to Brad Senko, who's online from NASA Goddard. But a big thank you, Federica, for a fantastic talk. Hi, Brad, are you there?
I'm here. Good morning, everyone.
Good morning, very early on the East Coast. Thank you very much for joining. I think we're just trying to pin you, maybe, and get your slides up. Just wait 1 second.
Sure thing. I can get started in the interest of time. So hi, everyone. My name is Brad Senko. I'm at NASA's Goddard Space Flight Center in Greenbelt, Maryland. You've heard 2 really nice overview talks from Jenny and Fed. I'm particularly glad that Fed talked a lot about the software infrastructure, because that's something I wasn't going to have time to talk about. Instead, what I'm going to focus on is really a hardware-focused talk and looking at the landscape in space, both the current landscape, the landscape in the near future, and trying to identify things that are missing when we're thinking about future missions. So if you can go to the next slide, please. I structured this talk. People like things that are in groups of 3. So I was motivated a little bit by Charles Dickens, but I don't want you all to think about, the satellites that I talk about as the ghosts of Christmas past, because lots of them are up there doing great science. But I tried to answer 3 questions. What are the capabilities that we have now? What are the capabilities that are coming down the road in the near term? And what are the capabilities if we really want to maximize this exciting new area in time domain and multi-messenger astronomy that we need going forward? Next slide, please. So we've been, next slide, thank you. So we've been really blessed for the last 15 years to have these 2 high energy missions in the field of gamma ray bursts that complement each other so well. The Neil Gehrels Swift Observatory, which can provide arc-minute and in most cases even arc-second localizations for of order 100 gamma ray bursts per year, working together with the Fermi Gamma Ray Space Telescope, which provides complementary broadband coverage over the entire gamma ray bandpass, all the way up to 100 GeV photons. Plus a very large field of view, seeing 2/3 of the sky with the GBM, everything that is not occulted to the Earth. This has allowed us to explore gamma ray bursts across a wide range of physics and in great detail. Next slide, please. Thanks to Swift, we've also had this capability to do rapid, which now means on timescales even in minutes in a fully automated manner. Moderately sensitive X-ray and UV follow-up. This is a capability that we've developed with Swift over multiple decades. You can see here on the right a plot of the number of target of opportunity requests that come into Swift. This is something that as we've developed over the years, I think the community has learned more and sort of become engaged more in. We're at the point now where we receive 5 of these requests per day, pushing up to nearly 2,000 per year. And as I said, thanks to a number of operational improvements, we're at the point now, really preparing in part for Rubin Observatory, where we can fully automated receive a trigger, slew the spacecraft, send it up to the spacecraft and start observations on a time scale within 5 minutes. So we think this is something very exciting going forward. Next slide, please. And thanks to the suite of, either great observatories or maybe you want to call them follow-on to great observatories, we also have this extensive suite of deep X-ray, UV optical, infrared follow-up from Chandra, XMM Newton, Hubble, James Webb Space Telescope. These are things that are not like Swift. They're not going to get 5 target of opportunity requests every day and respond within minutes, but they're much more sensitive, providing a much broader wavelength view, and they can respond to the most exciting targets on the timescale of a few days. So that's kind of the ecosystem that I would say we have now, but looking forward to the very near future, there are some very new and exciting capabilities coming online that I wanted to highlight here. The first is really, predominantly coming out of China, and this is in part with collaborations with Europe. But the Einstein probe mission, which was launched earlier this year, is a wide area. It's the first real astrophysics mission that's making use of these lobster optic telescopes to be able to survey, 10% of the sky to a depth that's more than an order of magnitude more sensitive than something like Swift can do. And additionally to that, it has onboard sensitive narrow field X-ray telescopes for rapid follow-up. The soft bandpass, the great sensitivity, the wide field of view has already uncovered, in just its first 6 months or so of operations, a slew of interesting transients. It's going to be great for gravitational wave follow-up, tidal disruption events, gamma ray bursts, a broad range of science. And in addition to that, after a number of years of development, the SVAM mission is finally launched just a couple of months ago. It's very much sort of a natural evolution of Swift, a Swift-like hard X-ray monitor, a Fermi GBM-like gamma ray detector, and the ability to promptly slew and point in X-ray, and in this case optical, not so much UV, but optical and redder, targeted towards high redshift gamma ray bursts. So as those instruments come online, I think there'll be a lot of exciting science coming out of that. There are many other missions coming out of China. I was there for a GRB meeting just a few months ago. And so that space, I think, is quite exciting in the sort of immediate future. Next slide, please. The other thing that's really transforming the gamma ray burst world is a new ecosystem of CubeSats and smallsats. The ability to cheaply get things up into space, the standardization that CubeSats and smallsats to some extent offer, and the fact that gamma ray bursts are really bright and you don't need a lot of area, a large telescope to actually detect them, has meant that there's been a really burgeoning sort of field internationally to launch these cube and small satellites to study gamma ray bursts. This is a relatively recent compilation. It's only the CubeSats. So the largest thing that's on here, is smaller than the check-in luggage that you all brought when you were coming to South Africa for this great conference. It doesn't mention small sats, Starburst in the US, Daksha in India. But you can see if you look at this, that this is including missions that are coming from a broad range of countries, including those that, may not have an extensive experience doing space-based astrophysics. This is a great way to get, new nations involved in this search. It's a great way to get students involved in it. And because of that, we're in this really exciting area where we basically have all sky coverage, although with limited sensitivity and localization capability. I'll come back to that at the end of my talk. Next slide, please. In the same way that, over the last decade plus, wide field optical surveys have opened up this really new window to study the time variable universe, things like Assassin, ZTF, Atlas, Pan-STARRS. The UV, at least in space, is really sort of the next frontier in that. It allows you to study things that are very hot, fast evolving, young supernova, the blue component to kilonova, tidal disruption events, variable stars. And so there are, three at least very powerful wide field UV surveys coming from a broad range of countries that will be contributing to this over the next 5 to 10 years. The Ultrasat mission is Israeli-led, 200 square degree field of view, really good sensitivity. We'll be doing, great sort of very high cadence surveys to look for very fast evolving sources. QVIC is a Czech-led mission, slightly smaller in sensitivity, but multi-band as it's designed, and still, great sensitivity to do gravitational wave follow-up. And UVEX was the next medium explorer selected by NASA, 10 square degree or so field of view, 2-band, far UV and near UV, going to do an all-sky survey, and can do target of opportunity observations for sources of interest. So this, like I said, the same way that we've been, exploring the optical time transient sky, I think the UV sky is going to be lead to a lot of exciting results over the next few years. Next slide, please. And the last thing that I wanted to highlight in particular, since a lot of the folks who are building this sit down the hall from me, the Nancy Grace Roman Space Telescope is going to launch in the next couple of years. And this was designed to conduct near-infrared surveys with an efficiency, a factor of 100 better than Hubble. In fact, time domain surveys of the high latitude sky for supernova cosmology and the galactic bulge for microlensing exoplanets are how it's going to spend a significant fraction of its time. And so even, if you're interested in cosmology, this is fantastic, detecting a large sample of supernova out to a redshift of 2 or so to pin down sort of fundamental cosmological parameters of our universe. It will be great. But in doing so, it's also going to survey, 10, 20, 30 square degrees with a very regular cadence. And so it will find all the other transients that are of interest to people who may not be interested in supernova cosmology. So thinking about how to make use of this, thinking about how it complements Rubin, how it complements the other facilities that are out there, I would definitely encourage all of you to do. There will also be a robust guest investigator program, at least 25% of the time over its 5-year nominal mission. And so people who are interested can propose to do their own surveys. If you're interested in finding, following up gravitational wave events, there's a target of opportunity capability. If you're interested in doing surveys of particular galaxies, all of those are open to your imagination and scientific persuasion skills. Next slide, please. Okay, so that's quick, what's coming. And so I wanted to take a step back for a moment and think about, what we are still missing or what we will be missing in kind of the near future. And so what direction, people who are thinking about, new missions, new capabilities might be thinking about. So I mentioned that there, we have this exciting new suite of small sats that will be providing all sky coverage at gamma ray energies for, joint localization with gravitational waves, whatever. And this is really, motivated by thinking about Jenny's talk when thinking about things like the A+ sensitivity, the 06 sensitivity, the Cosmic Explorer and Einstein telescope sensitivity. These are going to be so exquisitely sensitive instruments that, at a certain point, it's going to be extremely difficult to detect optical, infrared, radio, X-ray counterparts from these sources. However, the gamma rays, for the ones that are on axis, are extremely bright. And so I think that's going to be a, particularly important area when we're thinking about, upgrades in next generation gravitational wave detectors. So if you think about, this is a nice study looking at the sort of current and potential, future suite of instruments that are out there trying to do joint detection. They kind of fall into 2 categories. There are things that are like the GBM on Fermi that have very wide field sky coverage, and so could, in principle, detect a large number of joint detections with future high energy events. What exactly that rate is, at least 10 per year, something like that. But those provide very crude localizations on the sky. On the flip side, there are things like the Swift-BAT or the SVAM-Eclairs or potentially, the XGIS on Theseus that can provide good arc-minute localizations that those who want to do follow-up with, narrow field telescopes can use, but their coverage of the sky is much smaller. They're of order 10%, and so the corresponding event rate is going to be down by like a factor of 10. And realistically, you're looking at number of joint detections, it's going to be of order a few per year. We don't really have current or planned facilities that are capable of providing both all sky coverage and good localizations. I think this is a pretty critical need for next generation gravitational wave detectors. Next slide, please. Sensitive X-ray follow-up. Swift is providing moderately sensitive X-ray follow-up. Einstein probe can do that to some extent as well. But when you really think about where the gravitational wave network is going, you really need things that are more sensitive than Swift to get the bulk of the population. Even something like GW 170817, is at a distance of about 40 megaparsecs. You ask, how far away could you detect something like that, even with something that's, the sensitivity of Chandra or XMM, depending on exactly, what you assume for the sensitivities, you're talking about a distance of about 150 megaparsecs. So we're kind of at the range of what can be done with those facilities already with gravitational wave networks. Not even, what's going to be with the upgrades, things like Cosmic Explorer. So building sizable samples with really precise precisions, and this was really important for 170817, if you remember, there was an AGN in its nucleus having good angular resolution to resolve the afterglow from the nucleus of the host galaxy was important. To constrain the viewing angle to identify kilonova afterglows is really going to require improved capabilities, sensitivity, field of view, and PSF. Next slide, please. Rapid UV OIR follow-up. As much as, I would love to say that Swift is going to last forever, it's not. And so in thinking about, 5-10 years from now, we're going to have these fantastic ground-based surveys. They're going to dramatically increase the transient discover rate. Swift, it's not sensitive enough to match Rubin. Rubin is getting down to 24th magnitude, say, in its, individual exposures. And it's, has a finite lifetime. We're coming up on our 20-year launch anniversary in November. And so, the next generation of things that are doing this, real-time follow-up, ideally in as broadband as possible, in a rapid time scale. This is one of the benefits of space. You can do UV follow-up. You can do it immediately if you have a network of satellites. I think that's something that we're really going to need when thinking about how to handle things like Rubin. Next slide is my last one. This is not, sort of how we think about usual hardware, but I think it's a really important point, and I know that it's something that people like Mark Clampin at headquarters are thinking about, is communications, because that's absolutely critical for doing the rapid response science that we want to do. The sort of bedrock of the low Earth orbit communications satellite, which we call TDRS, which is a network of satellites that are up at geostationary positions. NASA is not planning on continuing that into the next decade. The hope is that commercial companies like SpaceX or whoever, Amazon, will provide replacements, but those are still really in development, and their requirements may not be the same as what we would want for, astrophysics. At the same time, we're really keen on getting more telescopes out beyond LEO, out to things like L2 or cislunar orbits where you don't have this large Earth occultation. And the deep space network is really, I would say, kind of overstressed at this point. And so thinking long and hard about providing the hardware infrastructure to do space-based communications for future time domain missions is really critical. There's a report that the Physics of the Cosmos recently put out that hopefully will be coming available. It has a number of recommendations. If you were at the last Astrophysics Advisory Committee for NASA, you saw a presentation on this. If you have questions, I'm happy to answer more about it, but I think it's something really important to keep in mind going forward. So with that, I'm glad to wrap up and take any questions.
Thanks so much, Brad, for that excellent talk. I think while we take questions and people think about questions, I'll ask the panelists to move over to the desk. And over there, please, everyone who is. And ask the floor as well as online. Are there any questions for Brad? Paul has a question, so Paul is going to the panel, Brad.
Hi, Brad. It's Paul Groot. On your last point about the hardware for the communications, what's the minimum size radio dish that you would need to actually be able to communicate with the low Earth orbit satellites?
So low Earth orbit is the relatively small radio dishes. You can certainly do that with things that are a few meters, and I think even potentially smaller, depending on what sort of strength antenna you have sending your signal down. There are commercial networks that are available and in further development that I think are going to do this for low Earth orbit pretty well. I think it's really more for the ground station type things, a deep space network question, because those require quite large dishes.
Thanks so much, Brad, for that excellent talk. We'll give a round of applause for you. Thanks very much. And I'd like to move on now to our panel discussion and see if we can get the slides up for this. But perhaps we can already start with introductions from our panelists. Thank you very much for speaking today. So I'll start with Paul.
All right. Sorry, Paul Groot, Radboud University, University of Cape Town, and SAAO. I'm also the PI of Black Gem and Meerlicht that was shown by Fed just now. So,
thank you, Ryan. I have your slide up.
Oh yeah. So my name's Ryan. I'm a faculty at Swinburne in Melbourne, Australia, and my interests are in pulsars and fast radio transients. So I'm a project scientist for the MeerTime project to do gravitational wave detection with Meerkat, involved in the PBTA, and I'm also do a lot of work on fast radio bursts. I'm PI of a project that searches for fast radio bursts with ASCAP, and and involved in an optical follow-up of FRBs as well.
Thanks, Ryan. Sankar?
Yeah, I'm Sankar. I'm from URL Satellite Center of ASRO, and my basic studies are on solar physics. I mean, I do transients of the sun like solar flares and CMEs. And I'm the principal scientist for the Aditya L1 mission, which was recently launched. And I lead a group called Space Astronomy Group. We do develop payloads for planetary, solar heliophysics, as well as astronomy missions. And I'm basically representing the ISRO for this panel discussion. Thank you.
Thanks so much, Sankar. To the AV support, apparently I'm getting WhatsApp from online participants. Their voices are not audible enough of the panelists. If we can increase. Thank you. Okay, and then Rob, I have your slide up.
Hello, everyone. My name's Rob Fender. I'm from the University of Oxford. I'm also a visiting professor at the University of Cape Town. So I have a long history of following up relativistic transients with radio facilities and also making wide field searches for serendipitous radio transients. And I have a lot of interest in the future of radio transient follow-up. Thanks.
Thanks, Rob. Roberta, I have your slide up.
So, good morning, everybody. I'm Roberta Zanin. I'm the project scientist of CTAO, so the Cherenkov Telescope Array Observatory. So in one sentence, I'm really a gamma ray astronomy. So I come from astroparticles, so I'm a physicist too. But we are entering, so this is a fairly recent field of study that was born in the astroparticle, but now it's really entering on tiptoe to the astronomy world. And CDA will be the first proposal-driven observatory that will open the data to the entire community. So we are here really to advertise this new facility where and everybody can ask for data and include the gamma ray data at very high energy. So we're talking about GeV, TeV in their projects, scientific projects.
Thank you, Roberta. And I also want to stress thank you to Fed also for mentioning high energy neutrinos, because I think, of course, they're a very important part of the picture as well. And then Brian?
I'm Brian Schmidt from the Australian National University, and I've worked on transients, specifically supernovae, but gamma ray bursts, but also outer solar system and stellar, usually focusing on the optical IR side of things, but pretty much anything.
Thanks a lot. Thank you. So in the next 15 to 20, 25 minutes, if you can all move into a bit of lunchtime, I do want to focus on our task at hand, which is specifically to think about global coordination. And our speakers did discuss this and touch upon some of the questions immediately. I'd like to also open to the floor as well as online participants if you do have any questions for our panelists. But I'll start off actually by following on from Fed's talk, yes, about what your perspectives or personal perspectives are about the challenges of actually having a global coordination network for basically follow-up or through multi-wavelength follow-up of these astroparticle events, yes, in terms of a question that comes up on the LIGO-Virgo-Cagra collaboration is why are the astronomers themselves not coordinating as we, in terms of LIGO, Virgo, and Cagra, are coordinating in thinking of being a worldwide network. So maybe you can raise your hands and I will give the floor to any of those who feel they would like to perhaps answer, as well as the audience. Brian.
I think Ed was right. It's sociological, and it's not insurmountable. We're very early days. We've only had a couple neutron star things to go chase after, and I think it will settle down if we start getting more. But it ultimately requires leadership and buy-in and an understanding of, if you are a person and put a lot of effort in creating a follow-up facility, how you're going to fit into the analysis in some way that's sensible. But it also requires the realization that your chances of actually getting anything out of your survey is actually not going to be very high when we are only looking at a couple percent of the sky, and probably having something of something is better than a lot more of nothing, which is kind of where we're at right now.
Thanks. Paul wants to follow up.
Yeah, I want to add to that of course, like LIGO-Virgo-Cagra, it is only 3 organizations, and astronomy has many, many telescopes scattered around the world. It's also a character trait. Astronomers are not physicists, and there's a reason why we became astronomers and not physicists. In the sense of high-energy physics, large collaborations. Many of us do not have the personality to actually work comfortably in a collaboration with 2,000 people. And that is something I think very fundamental to many of at least my generation of astronomers. Maybe the new generation is changing. But that is also something that creates a bit of a threshold into merging into a 2,000 astronomer collaboration, so that people do not feel comfortable in that. And therefore, there will always be people that break out and that will say, okay, I will just do it on my own. And that is something that we just have to acknowledge and have to work with.
Thank you. Are there any follow-up comments from, yes, Rob, go ahead, please.
Yeah, I just wanted to add that I think I agree with the points that were made, that in trying to create an international collaboration, it is mainly people that are the barrier. But I also think, we are not, transient astrophysics is not at the LHC phase. We do not need all the science to be done by one vast collaboration. And I think actually it's a good thing that small facilities run by individuals do have the chance to make big breakthroughs. And that's something that happens in transient astrophysics. And, if we all coalesce into a huge mega structure with one figurehead, I think that removes a bit of incentive for younger people to think that they might discover something.
Thanks. I'll pass it to Fed and then Ryan.
Thank you. Paul, you say it's a character trait, and very well, I mean, I do believe that there is some of that, some self-selection, but, you know, it's also a trait of the infrastructure that we have built for giving credit in astrophysics to the people, you know, the way in which we give credit for work. And so that we can solve. We might not be able to solve the self-selection problem, but we can work on making sure that our hiring practices change to reflect the changes in the astrophysics research system that do require more global coordination and larger collaboration efforts.
Sorry, just to react quickly to you, Van. Yes, I agree, that is possible, and there will be a scale from the small scale projects of individuals to the larger sort of physics type projects. But I think that fundamental problem will remain, right? It's very much in the nature of astronomers, I think, and it. Yeah, but it is something that I think needs to be acknowledged as well. No, it may not be slower. It may not change at all, right? Ever. And I think that is something that should be acknowledged. That is, you know, we are by self-selection different people, and we'll have to work with that, right? I mean, it's not ideal for this kind of things, but we'll have to work with it.
Thank you, Ryan.
Yeah, I think it's about culture and trust and openness. So I was wondering if the community should be thinking about becoming more open with sharing data, making things public like immediately, if that would help with this coordination or if that would hinder it. Like I work with telescopes where the data is public when it's, you know, comes off the telescope, and I was wondering if, yeah, exactly with facilities like Rubin, if that was the case, or if, you know, LIGO, LBC, if that was the case, if that would help things.
Thank you, Jenny, and then Beth.
She's actually had her hand up for a while.
Oh, sorry, Roberta, please comment.
Well, I was just to comment on this point, and I think I really think. I mean, maybe I'm a physicist and I come from large collaboration, but we can change, and we should point at the young scientists, and there is all the capability to really work together. But I think here we need to protect the environment, so the work of the single, as Federica was saying. So here the policies are fundamental. So there are three key aspects. If now we move to the broker world where you ask and you define the trigger of your observation, not more in the proposal, but in the broker, then we need a system. So we need to guarantee, I mean, a selection there, and we need to recognize the word so that everybody can reference to the use of that selection. But this is where the IAU, for instance, or organization, global organization, can really make a change and help.
I'll say I definitely agree on the finding ways to give credit to individual contributors. So the LIGO Virgo Cowgirl collaboration is always talking about this because we are that big kind of mega physics now. But I have a kind of a spicy question that I'll just throw out and see if anybody bites or just runs away in fear. Is it beneficial, really horrible, something in the middle if funding agencies start to apply pressure? Right, these are mega scale projects that we've got planned for the future, which are all really phenomenal and exciting. But if the best science will be done by, you know, this coordination, is it useful for the funding agencies to say, sorry, you have to kind of coalesce and change your culture, even though it's hard and scary?
Anyone want to, Brian, go ahead.
So it sounds good, except for we're not, if you're talking about 3 gravitational wave detectors around the world, no problem, because a small number of funding agencies control the variable. Let's just think of the follow-up of a gravitational wave source. So there is 100 countries playing in this, and so you're not going to be able to deal with the game playing. And so I think we have to create it as a norm within the field rather than to regulate it. We will be regulated on the big bits, and correctly so. We don't want to be seen as wasting data. But I guess I also want us to also think that we're in this place where we're assuming the localizations are going to continue to be poor. So there's a very big difference in all of this when you know that you, with your facility, have a 1% chance of getting the thing yourself. Then it's clearly in your, it's in your interest to collaborate, because otherwise you're rolling dice. That's just terrible. And the odds are against you. But imagine we have the Einstein probe. Turns out it finds every single, to high level localization, neutron-star merger. And imagine instead of just a tenth of the sky, it's doing 3/4 of the sky. Then you have a whole different set of dynamics that we're going to have to deal with. And I promise you, it's going to be every telescope to itself, because we're going to get on there and write our Nature paper. And that will be true for 1.5 years until Nature no longer is interested in this and moves on, and then we'll re-equilibrate. So I think we have to understand we're humans. It's a very complicated landscape there. We need to do the best we can to normalize the thing that gives you really good science, and that's going to change as we evolve here over the next 10 years.
Thank you. And I think Rob wants to follow up, and then Beth.
Yeah, just 2 points. So again, we're talking about mega facilities, but as Brad showed and as Federica showed and others have, a lot of the big discoveries actually come from really small facilities which follow these things up. And then on the aspect of whether or not everything should be forced to coordinate, I think there's, as well as the individuals, there's a financial reality, which is a lot of the people who fund facilities and small telescopes, which will make these discoveries, will not want to sign up to these things. So a lot of the funding for these facilities doesn't come from national agencies which might sign up. It comes from individuals or some other associations. So I think we have to have a flexible future where there are agreements, but we need there to be individual facilities which can participate as well.
Thank you. And then Beth, if you can introduce yourself.
Oh yeah, Beth Willman here. I'm largely part of the Rubin LSST ecosystem for most of the last 20 years. And to the points about changing norms, which are spot on, and evolving models of credit, and in addition to evolving models of credit, evolving norms of what an excellent leader looks like are already happening, right? And so in the time that I've been part of Rubin LSST, right, starting before the science book was written in the early part of this decade, right, we're at a period of time where there are more than 2,000 scientists around the world, astronomers, self-identified astronomers with a mix of physicists, who are voluntarily in self-organized science collaborations. There's 1,000 individuals in the dark energy science collaboration, a lot of astronomers joining on because they're realizing we're in an era where there's a lot of amazing small-scale science being done. I'm incredibly supportive of that. But it's also the case that we're no longer in the individual hero era in terms of pushing the envelope to the biggest questions. Fed told us there's going to be, 10 million alerts every night? And do we want to leave science on the table? There's a growing substantial portion of the astronomical community that wants to bind together and come together and coordinate. And it's not going to be easy, but talks like Fed's and conversations like this are going to push us in that direction. But I see it happening within Rubin. People are just trying to figure out how to do it.
Thank you. Paul, you want to follow up?
Well, not a follow-up, but basically a different point on the coordination, if I may, because there was the mention of the treasure map, which is a great initiative by Kavi at Tel Aviv. But on the question that was asked there at the back, so the treasure map actually allows you to submit your planned observations as well as after the fact updated with what you have actually been able to do. And I think that is a great facility that they have now enabled, so that, of course, things can happen. Your telescope can break, the clouds can come in, whatever, right? So, but it's good that in advance you can say, okay, we're planning to do this bit, right? And then others can react, because, a few of us are in the luxury position that you can say, okay, if it is 100 square degrees or a few hundred square degrees, we can actually cover 90%, right, within a few hours. But not everybody has that. So then plans can be adapted to that as well. And I agree with Brian that it really makes a fundamental difference whether the error localizations are a few thousand square degrees or if they get down to a few tenths of square degrees, which will change this whole game. But I think that I wanted to emphasize the fact that the treasure map allows both. So it's not just after the fact, okay, this is where we looked, and then the rest we will just have to piece it together. You can also do it in advance.
Thank you. Any immediate follow-up points? Yes, I was actually going to come to you, Sankar, as well, because we did discuss, or Brad presented some of the initiatives in space on the Chinese front, with LIGO India coming on. I also wanted to ask if you could comment on projects going on in India, as well as on the space agency side as well.
Okay, so before going to that, I mean, just to follow up on the current discussions, I mean, just to, if not for the continuing missions, at least for the future missions, we also follow this, what we call it as a target of opportunities for many of these space missions. So usually many of our spacecrafts, including the Aditya L1, what we are doing it is we allocate certain percentage of time for TOO proposals. And that is done very quickly. So within 24 hours, you can put up your proposals and go through it. So that is one mode of observations. I mean, I see it in many of these astronomy missions also. It's being followed. So that is something which I think as a international transient astronomy team, if you guys have a certain time for many of these space missions, as well as the same can be followed for a ground-based observatories. I mean, you allocate certain percentage of time for the transient observations, which can be enabled by the regional transient coordinator, for example. They can enable that particular observations and then go for the observations. And then the analysis can be done by the team of people which we can do. And our TOO, many of them, even for AstroSat, we have a TOO. Once it is observed, I think it is open for, the data is open for anybody to analyze the data. So a open data policy for anybody to look at it, even from the ground-based observatory, is a kind of a way forward, and allocate a certain time for the future missions. And that also would be a way forward. Especially for space missions, what we find it difficult is getting a ground stations, because many of the space observatories, if you want to get the data down immediately, or at least with a very small latency, you need a ground stations at multiple locations. That is an area where I think we always find it difficult to get a coordination going, because either it costs you to get a ground stations, or you have to have a more open collaborations through scientifically to get your ground stations done. Okay, coming to your discussions on the future plans of it, I mean, there is a team of people led by Varun. There is a proposal called Daksha, which looks at the, which is planned to look at the transient sky from soft X-rays to all the way to up to hard X-rays, including gamma rays, by a set of detectors looking at almost 4 pi directions in the sky. So many times what we find difficulty is it's a combination of the coverage versus sensitivity, because high energies, larger the field of view, your background will be larger. So if you want to get a high sensitivity, you have to reduce your field of view. So it's a combination of your field of view versus the background, which defines your sensitivity with which you can go forward for it. Maybe Varun will be a better person to talk about the sensitivity. It has a very large effective area covering the full sky. And so it would monitor the complete sky for transient events in the band from, say, less than 1 keV to all the way up to a few hundred MeV energy ranges. And then the project is in the study phase. I think they have done an engineering model at the place, and it's going into the project report generations before it is put up for an approval for a flying. Maybe if it gets approved, maybe in 3 to 4 years time scales, I think that this can be launched. Varun, you want to add? Please add to this if he's online.
I think Varun is online. Varun, would you like to add anything?
No, thank you. Thanks for the detailed answer. So if people want to know more about Daksha, they can just go to the ASI booth and you can get details there. Or I also have Utkarsh and Vishwajit, my students in the audience there. you could talk to them. Since the focus right now should be on the panel discussion, I won't go more into details about the same. Thank you.
Okay, thank you. So essentially go to the booth downstairs on the ground floor from the Indian Society for Astronomy. I'd like to maybe also move on to Roberta to maybe ask you, we have this fantastic CTA coming online, and if you can maybe mention something about the status as well as what are the challenges, in terms of thinking about multi-messenger coordination and the lessons that we've learned from, other astroparticle follow-up efforts.
Thank you for the question. So CTAO is about to start construction. So the plan now is fully funded, and we will have 64 telescopes in 5 to 7 years from now. But of course, I mean, it's a module, it's an array, so we will have soon, let's say in 2 or 3 years from now, the first telescopes really taking the first data. And when I say 2 or 3 years, because this is the time scale on which we will have enough telescope to be at least a factor 2 more sensitive than the existing facilities in the same energy range. So we start becoming really competitive in 2027, let's say. That's to give you an order of magnitude of what is happening. And then the initial configuration should be over, let's say, by the 30s. So that's the status of the project. I mean, we are working, and one of the key science case for us is the transient physics. So then multi-messenger and multi-astronomy comes in, and it's fundamental. We are really following closely all these developments on the brokers, on the softwares, because this is where the physics come in, and then we can make the difference, because you can. So what CTA observes is, let me make a step back. So is extreme phenomena, violent phenomena is an extreme environment. So we're looking at thermal and non-thermal emission from these environments. So wherever you're studying, so merging of black holes, gamma ray bursts, so all these extreme phenomena that produce non-thermal emissions at low energies produce also the non-thermal emission, high energies, very high energy that is often forgotten, but can add a piece, the other side of the medal of the phenomena. So it's where really I think it becomes interesting for the astronomers to look at. And then if I can, I will finish with a question, mainly to Federico, to you, to Robert, that before you said, okay, technologically speaking, and then I come back to the brokers, that's technologically speaking, that's solved, and it's solved since 20 years, you said, no? All fine, but don't you have any concern on the maintenance part of this software? So now we're building a new observatory, and then we want to trust this open source or anyway external software. How can I rely on them?
So the brokers that we are seeing in the Rubin ecosystem, which have really led the way on developing these very large, world public software like Antares, Alerce, think just to name a few. I think they're also applying really, really good collaboration and maintenance practices within. They're managed extremely well. And at least in some cases, the agencies are really recognizing the respective agencies of the respective countries, right? They're really recognizing the innovation and the importance of the software. I think, if I'm not wrong, I just heard that the Think software won a prize in France as an innovative technology prize. So, 4 years ago, that I would, stay awake at night thinking what are we gonna do? There's 10 million alerts every night. We don't know how to give them to the world. But I really think that they're very solid. The software maintenance and also the software credit policies, remain something that we need to focus on, something that we need to challenge, that challenges our infrastructure, but I think they're improving very fast, so I'm not that worried.
I don't have much to add. I mean, Federica's answer is the right one that's appropriate for now. I would say that the first two generations of people who were looking at this, they were very talented developers and they left astronomy and moved to the private sector. So this, I guess, is still a concern for good developers in astronomy. And I think not only is it salaries, but also giving credit, as you say, giving credit to software development is very important.
Yes, you're absolutely right, and that continues to be a problem, but the practices that we apply for building software in astrophysics now are rapidly changing, and they enable, passing on the project to the next generation of postdocs and PhD scientists until they get, poached away by industry. So I think, we do build legacy software.
Sorry, just to chime in, I totally agree, but this is one aspect, is the development one, and what about the operational one and the maintenance?
Would you? Okay, Paul, okay. No, and are there any questions from the floor before I end with asking a question to the panelists as well as on Zoom? Sure, Fed.
I mean to monopolize, but since I brought up the agencies, and if there are any agencies representatives here, back to the sharing credit and working on programs that really think about setting up collaboration and being part of collaborations. I think really the key point is going to be when the NSF, or pick your favorite agencies from your agency from your country, receives two proposals for building a follow-up facility that are identical, but one says, I will work entirely collaboratively. There will possibly not be any first author papers from my team, but we will work as a community. And the other one promises 10 first author papers, and the NSF picks the first one, not the second one. I don't think I live in that world yet, but I think we need to move to that word.
Thank you. So would you like to follow up? Okay, so I think in the last final minutes, I'm going to ask the panelists. We've focused quite a bit on the follow-up, but we also have some experts here in the room as well as on the panel on transients just overall, so fast radio bursts as well as potentially single sources from pulsar timing arrays as well as LISA in the future. And so I wanted to ask you essentially what concerns you most about current time domain science or multi-wavelength, multi-messenger science. What are kind of the key, I guess, questions or things that you think we need to address, or else basically something that you would like to impart to this working group in terms of the global coordination. So I'll start with you, Paul, and then we'll go down.
Okay, so first I think we've made huge progress on those first few points, right? I mean, that the Leica work is giving triggers 60 seconds after detection is fantastic. I mean, I remember the first workshop that we had on this in Amsterdam more than 10 years ago. And we were, as astronomers, we were pushing for a 10-minute time frame. And the Leica work people said, 10 minutes, not gonna happen. So it's fantastic that we're now at the 1 minute level. And I think that's matching our response times. So I think we see enormous progress also in the coordination. The next bottleneck is the spectroscopy. And the depth to, I mean, Ruben is gonna go way too deep for spectroscopic follow-up. I've said this from the very start of Ruben, and we still need to solve this problem. So I think that is what concerns me most, is our ability to get the most physics out, which often relies on spectroscopic follow-up. And not just a single spectrum, but a series of spectrum as an event evolves. And this is not just for gravitational wave follow-up. This is for any part of the transient and time domain astrophysics in general. That's my biggest question, worry.
So should organizations like ESO be thinking in the area of the ELTs of repurposing one of the VLTs, for instance?
I think this specific organization you mentioned is very much thinking about that, and Bruno is here as the science director of ESO here in the room. But yes, I think dedicating a VLT or a Gemini or a CAC, to this. Of course, there's pressure still from other fields in astronomy, and this is because as a field we've grown immensely over the last 30 years. Of course, there's pressure, but This is my worry.
Do you want to add anything, Bruno, or no? You're okay. Okay, Ryan.
Yeah, just to follow up, yeah, I think it is the fact that everything is going to become more distant and more faint that's going to force the coordination. Because if there's going to be 4 FRB follow-up programs on the VLT or ELT, only one of them is going to get out, or the panel's going to tell you to get working together. So that's why I'm really excited about that, and that's going to, this necessity is going to force coordination of things. And then, yeah, on the pulsar timing side, of course, what we're looking for is binary supermassive black holes, and these things are continuous waves from them. So what you're going to want to do is go and look in your favorite optical light curves for, periodic sources at redshifts of like 0.2 to 1, right? So this is going to require, again, coordination with, projects like Rubin to get access to the light curves to do these sorts of searches.
And I think also push from the computational and theoretical side in terms of being able to model what the signatures will look like.
Exactly.
Thank you. Sankar?
Yeah, so though I'm not from this particular area, but from my experience with Astrosat and Aditya, I think the major issues, major hurdles what I faced is combining the space and ground-based, because both of them works on a proposal-based mode. So when you have a transient alerts, how do you focus all the resources into a single sources? That is something which I think we don't have a process, at least in India. We don't have a process to establish how do we make a coordinated observations when there is an alert goes. So that is something which we need to work towards it.
Thank you. Rob?
Yeah, thank you for the opportunity to make what I think is an important point for radio astronomy, which is that, we know for a long time that in optical and X-ray astronomy, big discoveries of transients have been made and continue to be made by these small, flexible facilities, which can dedicate a lot, if not all of their time to transients. There is no equivalent in radio. So in the Northern Hemisphere, we operate an array called AMU, which are dishes that were built in the 1960s, and we keep it running, or the University of Cambridge keeps it running to observe transients. We find lots of interesting things. There is no equivalent facility in the Southern Hemisphere. So going forward, SKA will spend about as much time on transients, I would guess, as ELT will spend on transients, which is not very much, right? And that's understandable because it will be a super sensitive facility. And why would you want to spend thousands of hours monitoring something that you detect at 1,000 sigma? So we need we need at least one small radio array in the Southern Hemisphere, which will regularly monitor radio transients and will find those rare events that you only get when you sit on things for a long time. And I think it's really imperative. Otherwise, you're going to find transients and you're going to get very sparse observations and you'll miss a lot of the physics. Thanks.
Thank you, Rob. Roberta?
Well, I wanted just to echo what Rob said. It's not only in radio, it's true that in optical, for us, the optical counterparts are fundamental, not only for transient, but in general. And polarimetry plays a huge role there. So for us, and we made the exercise, so we are talking about, so we made some calculation that we would need for our key science project, 1,000 hours per year of optical polarimetry, for instance. This is something that is super expensive. But in photometry, it's much cheaper because it's about 100 hours per year. But both sites, because we have one site on the north, one on the south, and there it's where really we are even thinking to have an optical support astronomer inside CDA, because this is the kind of facility that can, with this facility you can save money at the end because we really need a lot of time.
Thanks, Roberta. And then Brian.
So I guess at the highest level, my worry is ensuring that as a field, astronomy is able to remain dynamic. So we have these opportunities to do these very large programs, as referred to, but I think we have to be very careful that we allow a range of activities that occur so that we get creative, revolutionary ideas that don't get squeezed out by simply everyone being part of large teams. And I think that's easier to occur than you might imagine, and we could easily find ourselves in a much less dynamic, less diverse scientifically field that looks a lot more like particle physics does now, which is, it's not the place to be like it was 25 years ago. And I think we have to be very careful that we keep a range of things happening, as you've just heard here, in both a sociological way, in a funding way, and an instrumentation way. And that means thinking about it.
Thanks so much. So I think on that note, we have overrun, which I apologize to all of you for overrunning into your lunch break here. But I would really like to make a few points. So I'd like to firstly thank the speakers as well as the panelists for attending this last session. I think as we could see from the discussion, there's a lot of things that we still have to think about, discuss as various communities. In particular, I think also to Matthew Collins, who is taking on the co-chairing with Rachel Somerville on this IAU working group. You know, I really think obviously transience does exemplify the discussion need in terms of global coordination, as well as for the IAU to take, I think, a leading role and continue to take a leading role in this. And we are producing a one-pager, at least, for this session. And so I'd like to encourage the online as well as the audience. I mean, please email Varun and myself. Varun, I want to say thank you very much for co-organizing this session. And so please do email, and I hope that we can have a continued discussion and workshop in the near future in this exciting era. Okay, thanks very much. Have a good lunch.
That was very interesting. I mean, very all over the place, but
Hi, Eduardo, are you there? Hi, Zach and Kelly. We're going to wait a bit.
Sure.
And Genevieve. Hi, Genevieve. We're going to wait a bit that because we're waiting the connection with the room.
Cause feedback. Cool. Perfect. Awesome.
Hi.
Okay. And I'll hold
Hi,
on.
Eduardo. Are you there?
Okay.
Hi.
Okay. Do you want to tell?
Okay. Let's change it up. So now I can begin?
Hi, hi, sorry.
Yes.
People are still coming in. Maybe we could wait another 2 minutes
Okay, it's fine.
and
No,
I'll
it's
start.
perfect. It's perfect.
Awesome,
Okay.
cool, thanks.
Just let me know when I'm going. I should to begin.
Yes. Okay, I think we're ready to get started if you are.
Okay, thank you so much. So, welcome everyone. I think it's you had a great lunch now. Okay, my name is Camilo Delgado Correal. I'm the co-chair, one of the co-chairs of the working group of AU junior members. This working group focuses on topics that are crucial to early career astronomers across the globe. These include careers, teaching, mobility, well-being, financial security, transparency, and diversity. Junior members represent the majority of active astronomers worldwide, which represent the future of the field, but also provide an invaluable influx of skilled workers to all the branches of society. So I would like to invite you to visit our information in AU. Also, during the presence of this General Assembly, this working group has prepared a schedule that includes the following topics: improving scientific writing skills, learning observation, science diplomacy, mental health management, time management, work-life balance, and public engagement in astronomy, communicating your research to the public. The scientific talks include the following topics: writing a scientific paper, improving writing skills, science diplomacy, transformative potential of a network of networks to support early career research with an astronomy education, engagement, communication, and culture, exploring astronomy as a tool for enhancing mental health, the role of peer mentoring in astronomy, or the roundtable of the offices, and unlocking inclusive outreach, connecting mind to science. So now I would like to invite our next speaker, that is Dominique Vertu, that with joyful Luli and Mafoledimi, they are talking about the exploring astronomy as a tool for enhancing mental health. So I would like to give the space for them.
Thanks, Camilo. Do we have the slides ready? Cool. And then it's the big green button. Okay. Thanks, everyone able to make it, and for people online. I can. Let me move it a bit up. That will be a bit easier. Yeah. Okay. Thank you, everyone. So today, we're going to be looking at mental health, time management, and work-life balance. So what I'm going to be doing with you is really looking at how we've been using astronomy as a tool to improve mental health and well-being, and how that can also relate to your time management and work-life balance. And a lot of it is based around acceptance and commitment therapy principles, which is a psychological framework that they use. And since there are not many people here, I'll leave a lot of time for questions so that we can make it more practical for the people that are here, and if there's anything from the people online. So for today, I'm going to look at mental health management, time management, work-life balance, and how all of this integrates with acceptance and commitment therapy. Now, the idea is that hopefully there will be some inspiration to engage in mindfulness and acceptance and commitment therapy practices yourself, some practical advice for how you can start down the journey of these self-care activities, and then also just some insights into how all of this can also impact your time management. Now, before we start off, I want to ask everyone to just think for yourself, what was the last time that you really felt amazed by something? It doesn't have to be astronomy related, but just the last time you really felt amazed or encouraged, and then how did that affect your week? So when you felt that experience or that emotion, and then a few days around it, if you can remember, just how that made you feel. Now, the reason I ask that is because when we're talking about mental health management, as much as our brains process information very quickly, our brains also like emotions, but they like to hold on to them. And it is very easy to get trapped in a bad mood or get overwhelmed by all the expectations and the work that you have to do. So how can astronomy help? So there's a lot of studies that we've been looking at that look at the effect that nature has on people's mental health and well-being. And we've been now pushing to see how can astronomy come into that. What it comes down to is if you just look at being in nature, you have that moment to disconnect. You're not constantly surrounded by all your devices. You're forced to actually be present in what you're doing, whether it's walking or looking at things in nature. And astronomy can take that a step further because now if you're engaging in dark sky activities like stargazing or just time outdoors at night, you're already having to focus a bit more on what's happening. You need to give your eyes time to adjust. So you're away from your devices for quite some time. And we've been saying that astronomy can allow you to, while you're looking out at the stars, it gives you the moment to reflect inwards as well. The example always used is the pale blue dot, where we're all placed on this Earth together in this habitable zone, and it's just the perfect environment for us. But it also means that we're all connected, and as big as our issues seem, if you're looking at it from a stereo perspective, there might be different ways to approach your problems. In a similar way with the overview effect for astronauts going into space, when they see the entire globe, there are no set boundaries. We are all connected. Now, how does all of this come in? So when we're talking about astronomy and acceptance and commitment therapy, what astronomy allows us to do is it allows to give us that space, that time for reflection. Acceptance and commitment therapy bases a lot of its work on having those moments. So what it looks at is you want to identify things that you value, things that drive you, the things that you're reaching for, whether that's personal or professional. But then when it comes to challenges, it wants to help you to see how, whenever you're facing a big challenge or negative emotions, that it's something that you're experiencing. It's not something that is you. It's not something that you need to change. And that is also where astronomy and especially stargazing and activities like that can help, because as you're looking out at the stars, you're not able to change what you're seeing on that night. You're not able to change their location. You're not able to change if there's clouds or not. And similar to your problems, it's important to acknowledge them. They are there, but you might not be able to change them. And that's fine. There will be problems you can change, problems you can't. But getting into a habit of having that reflection and knowing which are the things that you can work on and which are ones that you can accept but let be, allows your mind to have a lot more mental energy to move forwards. Now, one of the things that we have been working on is various resources. So there's a QR code up for all of these guided meditations, and I'm going to play one for you guys that I thought was relevant for the unwinding and the stress that everyone faces, especially in the astronomy field. So it is going to be a few minutes, so yeah, take a moment, get comfortable, and then we'll go through this and we'll continue the talk after.
It's been a hectic day. You've been on the go since you woke up. Your mind is whirring relentlessly with the thoughts of the day you've had. You feel your mind beckoning for a rest. Perhaps a walk would do you good, but you're quite tired and you need to unwind in the comfort of your home. Rather than a walk through nature, allow me to guide you on a walk through the night sky. To get the most out of this mindfulness practice, I'd suggest being outside under the night sky. But alternatively, you could find a quiet space indoors and allow your imagination to help you with this practice. Wherever it is that you choose to do this practice, make sure you're warm and comfortable. Close your eyes and purposefully soften your face. Relax your forehead and the muscles around your eyes. Let the tension melt out of your jaw and your lips. Let your shoulders relax. Become aware of the feeling of gravity, your body resting on your chair or on the ground. You don't need to move or do anything, just notice the pressure and the weight, the temperature, any feelings of softness or hardness. Know that your body is resting on the ground. Perhaps you're in a building, but under the building is the Earth, our planet Earth, made of soil and rocks and water, extending for thousands of kilometers beneath you. Earth is your ground, your stability, your foundation. Let yourself be held by it, and allow your tensions and worries to melt into it. Now turn your attention to your sense of hearing. Listen. If you find yourself trying to identify what you hear, try to put those labels to the side and instead allow yourself and the sounds to just be. Just listen. Don't worry, you're safe. Listen to the soundscape of the nighttime around you. There'll be louder sounds and quieter sounds. Allow them all in. If you get distracted and start thinking about something else, that's totally normal. Just let go and come back to your sense of hearing. Next, turn your attention to your sense of sight. If you're doing this exercise indoors, keep your eyes closed and just imagine your ideal night sky. If you're doing this outside, open your eyes and look up at the night sky. Now we've been out in the dark for a few minutes, your eyes will have already adapted to the dark. If the stars are out, can you see them twinkling? If it's a bit cloudy, can you see the shapes of the clouds? How they gently shift and billow and take on different colours? Try centering your gaze on one part of the sky, maybe a particularly bright star, and become aware of your whole field of vision, from the centre all the way out to the periphery. Allow your eyes to be filled with the vista of the dark, with a sense of wide-eyed curiosity and wonder. If thoughts arise about what exactly you're looking at, which constellation is it, which star is it, and so on, gently put them to the side. You don't need to know right now. Each star in the night sky is truly massive and inconceivably energetic. Some are many times more powerful than our own sun, and they've been consistently radiating light out into the cosmos for billions of years, across unimaginable distances. Space is immense. If the sun was the size of a tennis ball, The nearest next star would be 2,000 kilometers away. And you're resting here on the surface of planet Earth, orbiting the sun and a part of it all. The night sky is literally awesome. Awe is a feeling of reverence, of majesty. It's a word used to describe the feeling of being connected to something much bigger than ourselves. And studies show that experiencing awe, especially if we can experience it regularly, it makes us more resilient, more capable of shifting our perspectives on our everyday problems and worries. So allow yourself to bask in that feeling of awe that you get when you look up at the night sky, and appreciate that you are part of this amazing universe. And finally, bring your attention back to your body. How do you feel now compared to when you started this practice? Do you feel heavier or lighter? Do you feel more spacious or more concentrated? Feel free to stay here, immersed in your nighttime experience, as long as you like.
So I picked that meditation that was done by Mark, an astronomer who went into the mental health and wellness side of things, for two reasons. Firstly, it's one of the ones he did that was just about 8 minutes, so not too long. And secondly, to allow everyone to experience, a lot of people might find that very awkward, sitting for 8 minutes and actually listening through something. But it raises the question for everyone to think about, how much time do you actually give yourself to take care of yourself? It's very easy to rush after the next deadline, rush after the next project, but how much time are you taking to actually check if your body's okay, if your mental health's okay, how you're doing, how your relationships are doing? And that's just something to keep in mind as we continue through the talk. Now, the other way astronomy can help in just viewing our problems is, a lot of you have seen this picture throughout your career and your studies. When you're looking at scales, it's really hard to think of a different way to approach a problem. But the more you can think of just how vast everything else is, it allows you to sometimes get that shift that your problem is really important for you right now, but it's not something that's going to consume all of you. It's not something that you're going to carry with you for your entire life. It's a problem that you're facing right now. Now, when we're looking at how do you manage your time, time is always going to be a sacrifice. There's no such thing as full balance when you're looking at managing your work-life balance and managing your time. So a good thing to keep in mind is, when are you productive? When do you have energy? And that comes down to your own rhythm. So you've got the classical methods that everyone always advocates of, like the Pomodoro method, of where you break your task on certain things, so you'll focus just on one task for however long you set, 20 minutes, then you take a 5-minute break, you can go on to the same thing again or onto a different project. And that's called time blocking, which works really well. You've got other people that say, try tackle all the easier tasks first. All of those can work. It's things that you'd have to personally experiment with. But what is universal from especially all the latest studies is that you need to be aware, when are you most productive? You do not want to schedule a big work session if you know that you're someone that in the morning you just don't actually function. You take about a few good hours to have your coffee, sit down, get into everything, and then you actually only kick into full steam around about midday or even close to the end of the day. So that's where the rhythm comes in. Monitor yourself for a few days, and it can be as simple as WhatsApping yourself a message or something. Just try and ask yourself at the end of the day, like, when did you actually feel like, now you're in a pace where you're getting stuff done? That will give you a good idea of where's your main area of energy for the day. And usually it stays pretty consistent throughout the month. So that will give you an idea of, if you know you have a very challenging project or problem that you're working on, try and dedicate a big chunk of time during that productive area of your day where you focus on that. Then you can have the knowledge that anything else, any small things that you have to deal on, you can do that at the rest of the day. But you have that productive gap where you know you can really make progress into the thing that's stressing you. There's also a short sheet that you can use to help you. You're welcome to take a picture of the QR code if you want. It's a very simple one. Basically, it highlights some of the core values that people usually have. So it's family, creativity, health, learning, things like that. And then what it goes on is the same thing, trying to see when are you productive throughout the week so that you can just get an idea of where to schedule your biggest tasks. And sorry for those that missed it, we can go back to them later. And then, like I said in the beginning, there's the overlapping area of your work-life balance, but there will always be a sacrifice. If you're heading more into the personal life, you are going to be pulling more away from your community and work, the same for the other areas. And there's nothing wrong with that. A lot of people feel a lot of judgment for when they're spending a good month or few months just focusing on work. But it's not something that you have to feel negative about. It's something that is the reality of the career that you're in. What is important is you don't want to stay in one of the areas for too long, because that will mentally drain you. That will cause you to have an imbalance in the sense that you will start feeling that you're losing out. And that will affect, if you're now in the work area all the time, if you feel like you're missing out on community and personal life, your work will also start to suffer. So that's why you should try and see if you can rotate through them, but don't feel judged if you have a specific deadline or things and you're giving a lot of energy into one area. Now, I left a lot of time so we can have some questions because there's only a few of us, but if you don't have questions, you don't have to ask. But are there any questions? Okay, nothing at the moment. Then what I will say is things that are useful for reading up on for if you're someone that really wants to focus on the mental health side of your journey and start going into that. There's a lot of approaches that you can take. The reason we use the acceptance and commitment therapy is it's a psychological approach that allows you to see results quickly, and it's something that you can also build upon. It's very based on coping mechanisms and skills that you can develop. So I would encourage everyone to either talk to me or you can read more about it.
I have a question.
Yes, Zach.
Can you hear me?
Yeah.
I hear you very, very low. So, but you can hear me clearly.
Yeah, I can hear you clearly.
Yes?
Yeah.
Okay, great. Well, it's a very interesting topic. I think it's a shame that you say there are not so many participants in the room. I think it's a very important topic in research and right now in young community or younger researchers. And yeah, the tools are very interesting, but I don't know how to say what I want to say and not sound criticizing, but I will tell what I have in my mind, and please don't believe it's negative criticism. It's just that I don't find another way. So first, I don't know how familiar you are in the career of a scientist in astronomy, from bachelor to PhD. So how big is the amount of stress and unsatisfaction and competition in the field? So this is a big important thing, because I've been in this mental topic for several years, because I suffer for that. And I've been looking for tools and copying skills and so on, and nothing of that helped me, because main of the, I don't know if any of you in the room or online know, but many of these mechanisms are like for average population. And our training is not at all average. So the stress and the situations that we are put on is not average. So I feel like these tools are not really helping researchers. So I have this discussion with many psychologists and also therapists and people working in well-being and careness and these meditation trainings. It's not working for us. So this is something that, like, you are developing these things, you have to have very clear in mind. And if you don't have the training as a scientist, it's really hard to understand, really, really hard to understand. So if you are developing these tools, I really recommend you to work with someone that really suffered that and was able to conquer this situation, these mental problem situations, because it's not the same suffering. It's not the same. You are not suffering the same as the rest of the society, and the way that you solve the problem is not the same. So I mean, you and I can talk if you want, because I'm working on that on my own, and I have discovered many things of how for scientists it's totally different. So when you showed this podcast, it was so stressful for me, and I don't know if it was really relaxing for others. And I've been hearing these kind of tools for many years, and it's not working because our stress is so high. So there are different, maybe if you want to focus in how you can help society or kids or someone else. But honestly, for scientists, for researchers, I don't think this is the best way. Maybe it's a first approach, but it's not the best one, honestly.
Yeah, thank you for your comments, Zach.
Do you have feedback from others, or why
Yes,
did you decided to develop this? Yeah, I'm very interested.
Yes, so we have a team of various astronomers, psychologists, clinicians, and social workers. And the example session that we went through, that is a generic session that is geared towards the public as well. And yeah, when it comes to astronomers themselves, we had a small session that we did with IAPS, and we're continuing resources on that. Most of our resources is designed for general public. So we try and design various approaches that would benefit practicing astronomers, but our audience is global. So we want to make sure that we, as far as possible, avoid any issues that would cause people to withdraw from the experiences. That's also why we usually try and avoid too strong connections to spirituality, things like that. And then for professionals themselves, we are currently engaging as well with the staff at SAO and that, because yeah, they've also mentioned, similar to you, that they would value an approach that is just focused on astronomers. So that is something that hopefully will be available.
Yeah, it's not, so as I tell you, it's not the same. The level of stress is what it make the mechanism, right? There are coping mechanisms for lower stress, and like the one that you show, it's like for lower stress. But when you are in a very high level of stress, then it's a different way. It requires like strong input to your brain, to your sense, to your body, like to have something very spicy or run without stopping, like something strong. And this kind of meditation things is not for that. And it causes the opposite situation. Instead to relaxing you, it make you more stressed, because you say, why I'm not relaxing? Why I'm not relaxing?
No, so that's why I did mention that the meditation might cause you to feel stressed. That's a good indication of where you're at.
Yes.
And that's why I would encourage you, I don't know if you have acceptance and commitment therapy practitioners available.
Yeah, sure. I have all what you can imagine, yes. I've been through this process for years, and I'm still in the process. So it's a long journey. It's not something that you can solve in 6 months or 1 year or 2 years. It's a very long journey.
It's an entire journey of getting to know yourself and building up that resilience. So that's where I would definitely recommend using this as an indication that, yes, continue with that journey and make sure that you've got the support network available.
And one something that I really would like to address with you, because I think you are in the IAU, one of the people involved in mental health for the commissions, is that when you go to the webpage and you are trying to looking for help as an astronomer, you don't find that. What there is like how astronomy can help the well-being of like humanity or society, but not for researchers itself. So
Yeah, and
for
the website
me,
is very bad.
for me, it's really surprising that it's announced or it's telling that the International Astronomical Union is working on that, but it's not really working in for astronomers, right? So this is something that is missing.
That
There
is
is no
something
a
I
clear
can
guidance of
address.
help.
So for the Office of Astronomy for Development, we focus on using astronomy for development. So most of our outreach would be to communities and to develop the general public. We don't develop astronomy. So that is why our resources would always first start as projects affecting the community, affecting the population. Whereas if it was more focused on the development of astronomy, then we would first go towards helping the professionals.
Yeah, but what about for astronomers? So we don't suffer of mental problems. We don't need well-being or.
No, so that's why I was saying we're still working on what can we develop for the astronomers, but our main focus will always be using astronomy for the development of community and the general public.
Well, if at some point there is a focus for astronomers, I would encourage you not to do it the same way that you are doing for the community, because it's not the same.
Yeah,
and yeah, definitely it's different. And I will encourage more participation of the astronomers itself, because it's the people that there are the survival stories there, and we need that stories, because it's totally different. What I see with the rest of the people is totally different. And every time people is advertising for scientists, this exercise, this reflection, it's just not working. I mean, we know how wonderful is the universe. We feel the gravity. We we know the stars. We know all that, and we love it. But that doesn't mean we are happy. That doesn't mean that the system doesn't make us sick. Yeah. So it's two different problems, and I will not address them the same way.
Yeah, no, that's perfect. Thank you.
Hi, so I noticed a lot of your exercises are really catered to individual practice.
Yes.
So I'm wondering, because humans are social creatures, we can only kind of do so much in isolation. Do you have any tools for, I guess, group work?
Yes,
And also
so
to...
if you have a chance to head to our booth, we've been working on what are narratives that can be used, especially during stargazing sessions. So those are just short things to encourage you to think about things differently. So you'd be able to go through that booklet and get an idea of an easy tool to be used in a group. And then other things that we've worked on is we've had retreats, which are a bit harder to organize, but where we would take a group of PhD people working on their thesis, take them away for a week, where in the day they can work on everything they need to work on, and then during the night they could have all of these sessions to try and encourage them and build the coping mechanisms that would help them.
Okay, what about also for advocacy? Because I know a lot of, you can face external pressures and those folks might not understand that they're causing harm to your mental health. So are there any type of, I guess, advocacy and to build understanding amongst others on the importance of mental health?
Yes, so we've only started to try and advertise that people should take their mental health seriously and encourage the journey of improving mental health. For advocacy, as in equipping people to advocate for their own mental health needs, we haven't had any resources for that yet.
Thank you for your talk. I had a question. I come from Europe, and mental health there is quite okay, it's very valued. But for example, I've been working in Japan too, and their mental health is not as valued as seen as a taboo. And that how can I help someone that come from that perspective to kind of move in the instrumental exercise that you're proposing? I know it's kind of difficult, but do you have any tactical suggestion?
So the way that we're thinking of approaching that type of situation is through our regional offices that are globally based. We want to work with them to try and see what would work for their population. Because especially you mentioned Japan and a lot of the Asian region, they would approach it very differently than we would approach it locally. So we want to try and get them on board. We've sent out a call, but now we're trying to see how can we arrange funding for them to also do the practical experimentation of it, to see for their specific community what would be the best way. Because an important part as well is if we as an office are starting to run a project in a certain area like Japan, we also want to know that we're able to link up people for further follow-up mental health care. Because all of our interventions are, like mentioned, is largely individual things that you can practice and develop skills for, some things for group, but it's not a mental health treatment. So there might be a lot of situations where you require additional care or support, and that's where we want to know that where it's being offered, there's already a referral network available where people can reach the help that they need.
Hi, I have other question.
Yes.
What was the most challenging part of your work? What was the most difficult, no? That you, when you're doing the project, no?
So the most challenging part of our work remains that there's no knowledge base that specifically targets the benefit of using astronomy or the night sky to impact mental health. So we've got some research groups together and we're hoping to start various studies in the coming months. But even then, it's really exploratory work still at this point. There's not been any large-scale studies to say that using astronomy is beneficial over something else. So there's a lot of work that we can draw upon from eco and nature psychology. And generally, I think people accept by this time that being in nature is good. But we want to be able to answer, is astronomy, does it add, does it make it more beneficial, or is it on the same level? And that's really, I think, as far as I'm concerned, that's the biggest challenge, is having that empirical knowledge base.
It's true, no? You need the feedback, no? Because yes, I mean, you developed the tool, but now you need to check how was the feedback from the person that listened the podcast, no, and the other tools.
Yeah.
Yes, it's true. And do you know if there is someone else in the community that they are doing the same kind of exercise?
So as we've been going along, we've started slowly but surely getting some pockets of people that are on a similar path. So I'm terrible with names, but so when we do find them, we try and incorporate them into our research group, or at least see how we can support them. So I already know of, there's two individuals from America that the one's a nurse, the other one's a researcher, and they are really interested in seeing how can it help patients. So they've got access to clients and patients that they can work with. And then we've got some other people from the Netherlands that are very interested to see for the general public, how do they experience the night sky and how their experience of the night sky impacts on their mental health.
Okay.
But yeah, it's a very, very small niche community still at the moment. So if anyone does know of more people that are working in a similar area or interested in building up that knowledge base, we'd definitely like to hear from you.
Thank you so much. Yeah.
Hi, everyone. I'm Joyful Mdlili. I'm with the OED as well. I think maybe just to add on to one of the other challenges that Dom forgot to mention is actually having people to work with to develop these resources. Say, for example, you're saying, are we targeting this for astronomers? It's very difficult to get astronomers on board to come up with these resources on how best to help as well. So it's almost like, how do you get people to help them? And that is one of the challenges that we've also been experiencing, because we try to get people to like help out in those things, but then it's very difficult to get them to sort of kind of like come and sit down with us, and we have these discussions on what is it that we would want, what challenges do you have that you'd want addressed, and how can we go best to help with that. So yeah, it's also one of the things that makes it very difficult to tailor make resources for people if you don't have the people to actually help you make those resources.
Yeah, and I think that links with Zach's comments. It's you would have
And I want to
individuals that
say
are,
that exactly. If we
yeah.
include the scientists, then it will be different.
Yeah.
Sorry for interrupting.
No problem. I was about to say, yeah, that links in with your comments, but it's also one of the challenges, like Joy mentions. It's you're in a career where you're constantly under pressure to compete against each other. So it's hard to take out time to be part of a focus group to develop resources.
Well, I will be very happy to be part of the focus group. So one of my plan is actually to develop tools that I have learned for scientists. So
yeah, that will be awesome. I would love to collaborate with you.
Sure, you send me. I already sent you a request in LinkedIn, so we can be in contact, and I will be very happy to collaborate about that. Because, yeah, for example, you mentioned working with patients, which is something that I really want to achieve or connect in the next year, maybe, when I already have documented all that I have learned. And you know that in clinics, no, some patients are allowed to walk in the gardens because it's important for your mental well to be in the nature and so on. However, the clinics are normally in the city, so you cannot offer more or less the same for watching the sky. But there could be like some solutions, maybe half an hour in the clinic where the lights are off, so there is less pollution in the garden, so people can really appreciate the moon or the stars. So yeah, there are some things that can be done.
Yeah, definitely.
Yeah. Thank you for the input.
Yeah, thank you.
Thank you so much. I think we need to finish because we have other talk.
Yeah.
So we'd like to
so if
say
anyone
thank
else
you.
wants to reach out, you're welcome to email or get touch, LinkedIn, any way you can get hold of us. Please reach out and we can see how we can develop this further. Thank you.
Thank you so much. Now I would like to give the space for Jacqueline and the Donso, the role of peer mentor in astronomy. So welcome, Jacqueline.
Thank you very much. Can you all hear me?
Yes, you can share your screen. Yes, perfect.
Okay, so good afternoon, everyone. My name is Jacqueline Inchidanso. I'm a Banting postdoctoral fellow at the University of Toronto. And today I'm going to be talking about the role of peer mentoring in astronomy and specifically how it contributes to the retention and success of underrepresented women in the field. And to tell this story, I'll be talking about LUMA, which is a peer mentoring organization that I'm a part of. And I was on the leadership of this team for a year, and I'm excited to share with you some of the work that we've been doing. And also a very quick disclaimer, the stories and some of the statistics I'll be showing here are based on the experiences of astronomers in North America, which may differ from the experiences of astronomers from other parts of the globe. And so before I dive into the discussion about peer mentoring, I'd like to talk briefly about this idea of a STEM or a science identity. And in a nutshell, it's the recognition of oneself as being a scientist. And it consists of four main components. primarily interest, the ability to identify oneself as being interested in a particular scientific discipline, performance, or belief in one's ability to perform certain scientific tasks, being recognized by others in your field as someone who is capable of doing work in the sciences, and then competence, being seen as others as someone who is competent in whatever scientific discipline that they have chosen. And together, all of these constitute academic or scientific identity. But education and psychology research have established this idea of a science identity as a really important factor in determining retention in STEM fields. But there's another kind of identity that educators and social scientists are beginning to recognize as equally important, and that's our social identity, which has to do with the recognition and respect of one's social identities by your peers. And these social identities are numerous. They include things like your gender, your culture, your nationality, your religion, and so on and so forth. And the key thing is that our social identity is inextricably linked to our sense of belonging in the field. And that has such a huge impact on our career trajectory. And I really love this perspective from Antonio Porra Valverde, a dear friend of mine who's a postdoc at Yale University and the founder of the Senka Bridge program, which won the IAU Development Prize last week. And he put it this way: we cannot prioritize scientific discoveries while ignoring the humanity of the people that we work with. So mentorship has been widely recognized as an effective way to build people, help people to build a science identity, because it helps us to build competence. And this is true across disciplines. And often when we think of mentoring, we think of this one-on-one relationship between a mentor, so the person who is doing the guiding and is usually someone with more experience, and the mentee, which is often the person who tends to be younger or is less further along in their career. And again, many studies have shown this model to be a very, very excellent tool for success. But this model is necessarily hierarchical, which means that there's usually a power dynamic between the mentor and the mentee. And a power dynamic isn't inherently bad, but however, depending on the social and the cultural context of a relationship, this power dynamic can be abused, which can negatively impact the mentee and eventually limit or stunt their career growth. And so this means that while mentoring is useful, the nature of the mentoring relationship matters. So what is peer mentoring and how does this differ from the more common mentor-mentee system? At the heart of peer mentoring is this idea of reachable or accessible mentorship, where the mentee and the mentor swap roles depending on the specific needs of each person. And this creates a relationship that is grounded in shared experiences and in empathy. And if you've been in astronomy for any amount of time, you've likely received some kind of informal peer mentoring already. For example, doing homework assignments together, sharing job application advice and resources, sharing career advice, discussing uncomfortable experiences and how to navigate those situations with your peers. And so the very nature of peer mentoring targets our social identity so that people feel at home in whatever academic community that they're a part of. Therefore, peer mentoring really helps us to thrive holistically by targeting both our science and our social identities. And so consequently, there are several benefits, not just at the personal level, like I shared, but also at the institutional level, including creating a safe and welcoming environment for people to express their social identities, which has a long-term benefit for astronomy as a whole. And peer mentoring provides a framework to do just that. There's a lot more that I could say about peer mentoring, but in the interest of time, I'll refer you to this really great article by Ariana Long, which discusses many of the themes that I've raised here. So what does the current landscape look like for women astronomers in the US? So here I'm showing some statistics from the most recent American Institute of Physics report. And this uses data from the annual survey of enrollments and degrees, which surveys all degree granting institutions in the US. Just as a quick note, this data is publicly available, so I highly encourage you to take a look at it. On the left, I'm showing the number of doctorates earned in astronomy, and on the right, the percentage of bachelor's and doctorates in astronomy earned by women for the past 3 decades. And the takeaway from these plots is that the number of women earning astronomy PhDs per year is at a record high. So we're seeing a 25% growth in the past decade, or in the past 3 decades, with the most growth occurring in the past decade. And so that's really encouraging. We're seeing more women earning astronomy PhDs in the US. But when we look at similar statistics for Black, Indigenous, Latinx women in the US, so this is a similar plot as the one that we saw before, showing the percentage of degrees earned for all women. And the bottom lines show the trend for women from 3 underrepresented groups. And that trend has largely been flat and only started to rise slightly in recent times. So the story is very different for Black, Indigenous, and Latinx women in the US. And if we take a look at numbers at the undergraduate level, and if we even include bachelor's degrees and for women in physics, not just astronomy, we see a similar trend. For Black, Indigenous, and Latinx women, the trend is mostly flat. There's very little growth in recent times. The thing that is striking is that although the percentage at the bachelor's level is low, which signals a talent attraction problem, it's still higher than the percentages that we see at the PhD, which tells us that we're losing people along the way. We're unable to, not only are we able to attract talent at the bachelor's level, we're also losing people at the PhD level. So we have a retention problem as well in the field. And so LUMA was created to try to address this leaky pipeline problem that is impacting underrepresented women in astronomy. LUMA stands for the League of Underrepresented Minoritized Astronomers. It was founded in 2015, so it's been around for about 9 years. And as I mentioned earlier, it's a peer mentoring community specifically for Black, Indigenous, and Latinx women. It started off as a community for those in astronomy, but now we have expanded to include physics and the planetary sciences. I just wanted to briefly mention that LUMA is funded by the NSF and Boston University, and what this allows us to make all of our programming and resources completely free to our members. And so to do this work, LUMA serves graduate students, postdocs, and research scientists. Earlier, I showed some statistics on underrepresented women in the US, but we are more than just data points. In the next few minutes, I'd like to share some of the stories of a few LUMA members so that we can humanize those numbers. So I'd like to share a bit about our why, our vision behind LUMA. This is Catherine Espeat. She's a professor at Boston University. She's the founder and director of LUMA. She got her PhD from Columbia University in 2003. And after that, she followed on to do a Sagan Fellowship at Harvard CFA. Her research is on planet formation around pre-main sequence stars, and this was actually her claim to fame. She was one of the first people to identify protoplanetary disks around these young star systems. Another LUMA light that I'd like to share is Ariana Long. I shared a bit about her article earlier. So Ariana is the former LUMA coordinator and currently serves as the Chief Programming Officer for Vanguard STEM. She got her PhD from UC Irvine in 2022 and then went on to be a NASA Hubble Fellow at UC Austin. Right. Currently, she's a professor at the University of Washington, Seattle, and her research interests are on massive galaxies in the early universe, specifically the evolution of dusty star-forming galaxies at high redshift. And very lastly, I'd like to share a bit of my story. My name is Jacqueline, as I mentioned. I'm a advancing postdoctoral fellow at the University of Toronto. I took over from Ariana as the coordinator of LUMA last year. I obtained my PhD in astronomy from Texas A&M University in 2023 and became the 26th Black woman to do so in the US. I'm the PI of a GWST program targeting massive galaxies in the universe that have stopped forming stars very, very, very on in cosmic history. And so I shared all of these stories again to sort of humanize these numbers because it's really, really easy to just look at the stats and go, oh, you know, these are just stats, but then there are stories behind them. And it's important to understand our success in the context of the landscape that we are faced with. So once again, I'm showing the percentage of PhDs earned by Black, Indigenous, and Latinx women, highlighting the fact that these numbers are abysmally low, partly due to poor retention from the undergraduate level. And if we look at some more results from another study by the American Institute of Physics, they found that in general, women of all groups are more likely to drop out of physics majors due to discrimination. So now we're starting to look at the reasons why we're starting to see this leaky pipeline, primarily first for women of all groups. And again, when we look at specifically underrepresented women, this problem is exacerbated, this problem of discrimination, which makes them even more likely to leave the field at the undergraduate level. And so there are many, many reasons other than discrimination that impact the career trajectories of underrepresented women in astronomy. I'm going to talk briefly about one of the major ones, which is financial barriers, for instance. So over here, I'm showing results from a very new study by the American Astronomical Society CSMA Poverty Survey. And the study has been recently IRB approved, and they got over 700 responses, trying to tackle the question of how much does this financial issue impact people's career trajectory in astronomy. And so this study is PI'd by Carlos Vargas, and then the data analysis is led by Taylor Hutchison and John Cohn. And I'm going to show the responses to one of the questions that was asked. So the question says, select all of the following statements that apply to you. So looking at specific indicators that impact the financial well-being of different astronomers at different career levels. And so the first one was, my finances have hindered my ability to study astronomy. The second indicator was, I lived at home during undergraduate school in order to save money. The third, I have had to choose between obtaining my basic needs like groceries, rent, medications, because I could not afford to pay for everything, and pursuing my career. The fourth, I've been a recipient of the Supplemental Food Assistance Program or food bank. And fifth, I've neglected medical, dental, and or vision treatment because I didn't have health insurance and or couldn't afford them. And so we're going to look at the responses to how many of these indicators were significant factors in the career trajectories of the people that were surveyed in this study. And over here, you can see that almost 50% of underrepresented women, specifically Black, Indigenous, Latinx women, indicated that 2 or more factors impacted them in their journey in astronomy. So this is a very, very real issue that underrepresented women face. There are many, many other issues that I don't have the time to go into, but very briefly, the other issues and challenges facing underrepresented women in astronomy are academic preparation gaps, imposter syndrome, cultural alienation. So it's very, very common to be one or the only person in undergraduate classes or graduate classes, for instance, meaning that there are very few people that you can relate to, which then means that there's very little guidance about the hidden curriculum in academia. There's stereotype threats and tokenization, fewer role models, the climate of exclusion that's generally pervasive in academia. And if you're from the global South, like I am, you might be faced with immigration challenges or have language barriers to entering the field and staying in it. And so as a consequence, we're seeing this lack of retention, lack of support, no sense of belonging, feeling robbed of your identity, loss of passion and joy for science. So these are very, very real issues that are impacting astronomy at the personal level, and I would even agree at the institutional level. And so it need to be seriously addressed. And so and this is an excerpt from the article that I mentioned earlier by Arana Long. And she mentioned that in the end, she only persisted. So she only was able to overcome all of these challenges that I just went through because she had mentors and peers who offered encouragement and respite. And so this is our why. This is why Luma was created, to formalize these systems of support and encouragement and to make them more accessible to as many underrepresented women as possible, specifically Black, Indigenous, and Latinx women. And as of now, we have 130 members scattered across 5 countries and 63 different institutions, and we've been around for 9 years. So we're a growing community. This is a collage of a few of our members. These are a few of the countries that they're located in. So although people are located primarily in the US, we have members in Canada, in the UK, in Mexico, and in the Netherlands. I also want to highlight that because this is a virtual community, it's completely online. We don't meet in a specific location somewhere. This helps make it more accessible to more people. And so LUMA currently serves graduate students, postdocs, faculty, and research scientists. The nice thing about this community is that we have people across different career and life stages, different nationalities, different areas of scientific expertise and whatnot. And so there is a broad pool of expertise to fuel the peer mentoring system that we have running here. And so the way that we run Luma is to provide several opportunities for support and connection in a choose your own adventure support and format. And what that means is that the members can choose whatever level of support that they need in varying levels of cadence and levels of commitment. And so members can opt into whatever programming fits their needs most at that particular time. And so here are some of the main programs that we offer at the moment, and new programs are being developed by the day. First, we have resource dissemination and individual support. We have workshops, we have writing circles, we have accountability groups, and we have social hours. So I'll briefly talk about each of these and how we use them to provide support and encouragement for our members. So first, we have a dedicated space for members, which is on Slack. This is a space where our members can just feel free to interact with other members. And specifically, we want a space where they can feel seen and valued as scientists, as members of the community, spaces where they can safely vent about any issues that they may have faced, such as harassment or discrimination, without the fear of repercussions. And this is really key. We want a space where they can receive validation and support in developing and expressing their social identity, as I mentioned earlier. The other way that we provide support for our members is through resource dissemination. And one of the ways that we are doing this is in partnership with the National Center for Faculty Development and Diversity. It's one of the leading providers of professional development in higher education. And what we've done is every LUMA member receives a complimentary one-year membership to NCFDE. And so they have on-demand access to a wide range of resources. For example, resources on navigating academia, dissertation support, writing challenges, webinars from experts in education and psychology and different fields, and so much more. And so this is especially helpful because since LUMA is spread across different countries and different time zones, not everybody might be able to make the group meetings that we have, but everyone has access to this online resource that they can then use at their own pace for whatever needs they might have at that moment in time. And then we have workshops, and these are specifically designed to equip members with the tools to tackle challenges that are unique to underrepresented groups. And for this, we invite women or people in the field who have a career trajectory of supporting underrepresented women in the field so that they can share the lessons that they've learned along their own journey and lessons that they've learned in their own careers. So some examples of workshops that we've had, for instance, are with Lucianne Walkowicz. The workshop was titled Navigating Your Way to Success with Roadmaps, where Lucianne shared some of their experiences in the field and how to tackle problems commonly faced. Another example of someone that we've had is Jessica Harris, where we talked about this idea again of a STEM identity, a social identity, and then navigating that in various academic spaces. We've also had the now president of the American Astronomical Society, Darren Norman, where we learned about establishing an astronomy identity as part of your career development. And then lastly, we've had Sarah Seeger, where we talked about keys to confidence, developing tools to become more confident in various things like public speaking, things like approaching people and building your network. And so these are just a few examples of the workshops that we've had. We've had several more in the past, and we continue to have them once a month to equip our members with the tools to tackle the challenges that I mentioned earlier. And so another thing that we have is these writing circles. These are daily accountability groups for members working on various writing projects. These could be papers, dissertations, other writing projects. As what we do is at the beginning of the day, a prompt will go out. And typically these are groups of 5 or more people. And so members will state their goals for the day, the chair on their circle, and then check back in at the end of the day to talk about how much progress they've made or not made and why that might be the case. Areas where they might need support or encouragement. And so these writing circles are really, really useful for just powering through any writing projects that people might have going on and then receiving support and encouragement along the way. And then lastly, or last but one, we have these accountability groups, also known as Luma buddies. So here you are paired with groups of 2 to 4 people, and you support each other to reach a very specific goal or set of outcomes. And these goals can be either personal goals or they can be academic goals, like job applications, talk practice and feedback, or if you just need a co-working space to be able to feed off the energy of other people as they are working on a particular project if you're not particularly feeling motivated at that point in time. Another thing that we've started recently in partnership with an organization called Movement Consulting is the Lightning Collective, which is a co-working space that happens every week for members that just want to get together with other people and work in a safe space as they work to achieve their academic goals. And then finally, we hold social hours monthly to enable members to get to know each other and to bond in an informal setting. Of course, doing anything completely virtually has its unique challenges, but this is one of the ways that we try to maintain that sense of community, even as we obtain new members and to try to forge these connections across the generations of members that we have. So these are a few testimonials from 2 of our members. The first is from Diana Powell. She joined Luma as a postdoc and is now an assistant professor at the University of Chicago. And Diana specifically mentioned this. This is something that was really striking to me, that this connection with the grad students at the time and the postdocs and the faculty who further illuminated her future paths showed her that she was not out of place in astronomy at all. And in fact, this was really, really life-changing for her because the support in Luma, and every time she runs into a Luma Light at a conference, just fills her with joy. The second is from Erin Cox, who's an NSF Accent Fellow at Sierra Northwestern. Erin also joined Luma as a postdoc. She was feeling particularly burnt out in her research, unsure of where she wanted to go with her work. She attended a workshop that was open to Luma members. And at the time, even though it felt impossible, she was able to accomplish her goals through the writing circles. She found the accountability she needed and the camaraderie that she needed, and credits her most recent publication at the time to these accountability writing circles that we provided. And so, yeah, we have a system that is able to provide support and encouragement and connection for underrepresented women in astronomy to achieve their career goals, which eventually helps in the retention of underrepresented women in astronomy. I'd like to briefly mention a few community initiatives that Luma is a part of. So a lot of our members are also involved in organizations doing similar work like Black and Astro, Vanguard STEM. And so we partnered again with Movement Consulting to provide workshops that are tailored specifically to the needs of the leaders, the members of these organizations. And we advertise these widely on social media as well. And so if you're part of an organization that would like to partner with Luma, I would love to chat virtually on Slack. So please reach out about that. Another way that we aim to provide value to the astronomy community is by providing workshops for mentors. So if you're a professor or a research scientist or a postdoc who's mentoring someone from an underrepresented group, we partner with Movement Consulting to provide resources in order to help foster healthy mentor-mentee relationships and to help mentors create a welcoming, respectful, and nurturing environment for their mentees. And so again, if this is something that you're interested in, please don't hesitate to reach out about ways that we can partner with you in order to make this happen. I'd also like to mention, so because Luma serves specifically graduate students and upwards, so graduate students, postdocs, faculty, research scientists, these are just a few resources for undergraduates that I wanted to highlight. So these are similar programs for undergraduates and post-baccalaureates. The first is the Unbound Community Mentorship Program by Vanguard STEM. They're currently taking applications. So if this is something that interests anyone in the room, or this is something that you think would benefit someone that you know of, please feel free to share this with them. Specifically, the Unbound STEM program is not just for people in astronomy, but also people interested in astronomy-related careers like science communication, science policy and advocacy, project management, and so on. A second program I'd like to advertise is the National Radio Astronomy Observatory NAC program. This is something that I was a part of as an undergraduate, and I really benefited from it. And it's particularly useful for students who want to gain research experience as well. So similar to LUMA, they have this long-term mentoring model with the added advantage of being able to participate in a research experience. So again, LUMA doesn't cater to the undergraduate population, but these are examples of some programs that do. And so I wanted to just briefly advertise them. And so LUMA is currently headed in by Carden Espaya, who was the founder and director. Currently, the coordinator is Junelli. I stepped down recently and then handed over to her, and she's the one who's spearheading a lot of the wonderful work that I've just highlighted and shared with all of you. The assistant coordinator is Sabrina Khan. And so these are the people that I would encourage you to reach out to if you have any questions about LUMA or you would want to partner with LUMA in any way. And so this is how to stay connected with us. LUMA is on X, formerly Twitter. We also have a website that has more information about some of the programs that I mentioned. And this is our email address as well, if you have any questions or you'd like to reach out to us about any of the things that I mentioned. So I regret not being able to give this talk in person because it would have been lovely to connect with anyone who has specific questions about LUMA, but I'm available on Slack to answer questions and to chat more about LUMA. I also want to briefly mention that we are at the AAS. So if you're going to be at the American Astronomical Society meeting this coming January or in the summer, please look for our booth. We often have representatives there who are more than happy to chat with you about LUMA, give you resources like flyers if you know people in your respective departments who would be interested in what LUMA has to offer. And of course, we have swag as well, t-shirts, mugs, and things like that. So if you are ever at the AAS meeting, please feel free to stop by and to chat with us. So just to summarize, peer mentoring is a really, really effective tool for contributing to the retention of underrepresented groups in astronomy. And here with LUMA, we're starting to build a community of Black, Indigenous, and Latinx women where we support each other in reaching our career goals so that we can thrive and succeed, not because of, but in spite of the challenges that I mentioned. And so I'll stop here and take any questions. Thank you.
Is there any questions for Jacqueline? Thank you so much for your talk. It's really impressive the work have been done.
Thank you.
Yes, I mean the community that had you. And what is the total number of the persons?
Yes, so currently we have a membership of 130 women, and that number keeps growing by the day, which is pretty astounding given the statistics that I showed. There are not that many of us to begin with, so the fact that we have this sizable number is quite nice.
Okay, yes, pretty big. Okay, there are some questions from the audience in the presence, and after that we're going to go to virtually. So there is someone in presence there that have questions. Okay.
Hi.
Oh, yes.
Yeah, I have a question about your engagement numbers because I'm wondering what are some of the challenges to that and how often are members able to join the virtual meetings, especially with the challenge of different time zones and just being generally busy as a graduate student, postdoc, et cetera. Can you speak a little bit about how many members are able to make the monthly workshops and other meetings that you have?
Yeah, absolutely. That's a great question. Having people in different time zones, even in the US alone, has posed a challenge for us in the past. And so that's something that we've had to really think through and think about ways to mitigate that. So in the beginning, as you anticipated, attendance at our workshops was low because we only had these workshops once a month, and they would occur at whatever time was convenient for whoever was organizing them, right? So attendance was quite low, about 10% or so. And so something that we've done recently to try to improve attendance is to, number one, increase the number of opportunities for engagement. And so, for example, like I mentioned, we have both daily, weekly, and monthly opportunities for engagement. And so if people can't attend one, they can often attend the other. And so we've noticed that with increasing the number of opportunities for engagement, we've seen the total engagement, so not the engagement at one particular event, but the total engagement has actually grown because people feel like they have multiple avenues to obtain support. And so now we're seeing engagement more at the 50% level.
I think there's a question on Zoom.
Yes, Zach, would you like?
Hi, thank you. Is no other question in the room, so I can wait.
No, that's perfect. Over to you.
Okay, thank you, Jacqueline. It's wonderful, wonderful talk and an amazing project. You know, when you finish, I would love, like all of us are in the room, and I would like to both of you, like Simone Biles and the others, gymnastic did to this Brazilian gymnastic in the Olympics this year. Did you saw this picture when she won the medal and everyone was bowing? I want to do the same with this project because it's amazing. I think it's the most beautiful project I've seen in years. Thank you for working in this. Definitely we need to work more in minorities. And I'm so amazed for this project and the work that you are doing. And one of the things that I was more happy that you show, it was the statistics of the poverty, because poverty is connected to all the problems, you know. And actually with one of the is one of the main issues in mental health problems in researchers. So how this is connected with all the other problems, jobs opportunities, mental health, well-being, connections, networking, everywhere it's connected with poverty. So I'm very happy this group is really doing, finally someone is speaking about this big issue, because it's the big elephant. No one wants to talk it, but we all know that it's there. Poverty is one of the main walls for many developments. So I'm very happy you show that. After telling all the amazed that I am, how can people, I have two questions. How can people from no US or the American continent can collaborate? Like, for example, I am in Europe, but I also a minority, and I have an outreach project who is helping minorities with a migratory background, for example. So this is my focus, minorities. So how you can open the door for people to collaborate with you. And the second one is if you would like to also collaborate with other groups that are doing mentoring, because nowadays it's very common, mentoring programs. Actually, I applied for a mentoring program with people of the Max Planck Society. Some alumni create a mentoring program, and they are helping students, because this is one of the main issues when you are a student. You don't have anyone that really help you and guide you in the system. And so this is how it's working. So maybe you can also say how you can collaborate with other mentoring programs. So these are my two questions.
Wow, thank you so much, first for your feedback and for your comments. It means a lot to hear that our work is appreciated. And the comment that you made about poverty, yeah, this is, I believe, the first time that a group is doing such a comprehensive survey on the impact of poverty in astronomy. I know that's something that definitely impacted me as a graduate student. And it was incredible to just see some of the first results coming out from the data, the first phase one of the survey. And so it's a very real problem. And like you, I'm really glad that we're starting to have some data and some stats on the real impact in astronomy. So to answer your two questions, how do we collaborate with you, specifically with your mentorship program? I'm so glad you mentioned that, because we would love to have you, for instance, if you you have any expertise that you would like to share during a workshop, for instance, that's something that I would love to chat about, or to collaborate for something like our group meetings. And so, unfortunately, I can't see you because I'm virtual, but please let's connect on Slack. I would love to chat more with you about that. And then I believe your second question was about how we can collaborate with you with your mentoring program that has to do with
How can we collaborate with others mentor programs? Yeah.
With other mentoring, right? So it will be similar through one of the 5 avenues that I mentioned, the group meetings in particular, or one of our community initiatives. And so I think we can chat in more detail in Slack. But yeah, thank you for bringing those 2 things up. In general, we are very, very happy to collaborate with other community organizations and with the one that you mentioned. And so I would love to chat more about how we can do that in more detail.
Great. And just one comment is that you have the web page and you have Twitter channel, and now you are using Slack, I think, for Luma.
Yeah, so I should clarify that the Slack space is specifically for members of Luma. So these are people who, who have been accepted into Luma. The Twitter page is public, so that's accessible to everyone just to keep up with the work that we're doing. And then the website is also a public avenue for people to keep up with the work that we're doing.
Yeah.
So the Slack space is a dedicated space for Luma members exclusively.
Yeah, well, I will suggest that also include like a LinkedIn channel for the project, because then you can connect more. Not everyone, I mean, maybe in US it's very common to have Twitter, but I think it's not for the same. It's not the same for the rest of the world, maybe. So to have more channels, it would be nice. And also, I was trying to find the project webpage before you show it, and it was hard because there are many other Luma things. Yeah. So yeah.
Yeah.
maybe in the logo, because I love the logo, it's very nice. Maybe in the logo put Luma mentoring, so people can look Luma mentoring. Just a feedback.
Yeah, no, those are both great suggestions. I hadn't thought of creating a LinkedIn page for the group, so we'll definitely look into that. And yeah, that's a challenge that we ran into. I think there's another women's organization called Luma, and that's the first thing that pops up when you Google Luma.
There is a Luma AI tool too.
Oh, really?
Yeah.
Yeah, so it's a problem, but that's a great suggestion. Actually, adding Luma mentoring to the logo might help alleviate some of those issues. So thank you.
Thank you for all the answers.
Yeah, thank you very much as well.
There are other questions. So I think we would like to say thank you, Jacqueline, to be here. And we finished this session, and we would like to invite you in a half an hour, no, to do the final session of junior members. So see you in half an hour. Ciao, Jacqueline.
Thank you. Musique. Vraiment,
donc ye mpe azoloba ke azomona nani ya ndeke
soki osave yango na nini wana emonana te
ya pdf
basali biloko na bango yango kitoko te
so na save na pdf
emonana si save na pdf nde
save na pdf sikoyo ezala wana talanga ba présentation kuna gabita na sisi na mama mbongo. Bush. It's fine. It's clear. Una tindelia na WhatsApp. Tindelia na email. It's clear. Don't tell me anything anymore. This is a lot of job. A lot of work. Yeah, a lot of work. This, yeah, no. They must change it. They must change it. They must just send the invoice. That is all. Yo, about some salad there. time is the next session starting?
3:30. 3:30.
3:30.
Yeah.
Okay. I'm gonna sit here so long.
Is it on? No, no, but I am at the OAU. Maybe, yeah.
She therefore henceforth got money. Hey, did you finish the money?
I'm trying to transition to a certain education.
She wants to hang it somewhere. She wants to hang it in her son's room. She's trying to really? You want to hang it in your son's room now? Let us go to your room. She was work hard. Every morning he gets up. You must get up in the morning and realize. He must realize I'm not doing well enough. How many awards do you have? I forgot an award yet. What awards do you have? Oh, that's during the PhD. Listen, what award do you have? You can hear they're saying this was still during PhD. It is not important at all for you people that absolutely have no awards or whatsoever.
Yeah, which I am slowly learning because I just met
Look at me, I'm joyful of life.
part-time still at the
I've never gotten an award for anything.
Yeah, right. Everybody's happy. So how can I not be? And plus, I have joy in my life.
Yeah.
And she said she was to bring joy to everyone.
I know with Kevin. I work for Kevin.
I think we only exchange. Yeah. I'm stealing away everyone from.
No, I'm gone.
At least we can support from the outside.
Yeah, we will help
without getting involved in the politics. Plus, you know that you are looking. These three are the three directors of APAS.
Yes.
So wherever we go, until we actually resign or something, the three of us are the legal with the legal directors.
We own all of you.
All the money, all the property. Look, if we of us decide to sign something,
If the three directors, it's actually true. If the three directors decided to be giving bonuses to the directors, we actually. Oh my God.
So this is an actual. Yeah. Hey, guys.
Exactly. Actually, don't notice it. We are all in the same room together and the same time. This is not good. Imagine if this part of the building just collapses. I think we need bodyguards. You're right. Look, he just gave us already a the whole room is in danger. You know what?
Yes,
So that this part collapses harder. Joyful.
I am going to the other side of the
Oh, the little bit. You're the only one standing now. Who are like, you're not tired.
Hi. Hi.
Hi, Camila. Hi.
So we can begin now or can wait some minutes?
Um, I think we should probably wait 2 more minutes. Kelly's supposed to be part of this, right?
Yes, yes, it's
Yeah,
true.
Kelly's not here yet.
Ah, okay, okay. No, we need
Okay,
the,
Kelly just arrived.
I mean, we need Kelly also. I don't know if Kevin is there or someone from the development office also. Yes, okay, yes, because we need a representative for each office to do this panel. Because I'm going to ask some questions. There are 2 questions. And the idea is to have other questions from audience. And we're going to have 5 minutes per answer per speaker. Okay, so we can wait. Just tell me when I can begin. I'm here.
Camilo, can you hear us?
Yes, yes.
So the
yes.
table is now set. I think we have everybody, so anytime you want to start.
Okay, so now we can begin. So welcome. It's a pleasure to be here with you. I'm going to talk about a little bit about the working group of the IAU junior members that are focused on topics that are crucial to early career astronomers across the globe. This includes careers, teaching, mobility, well-being, finances, security, transparency, and diversity. Junior members represent the majority of active astronomers worldwide, which represent the future of the field, but also provide an invaluable influx of skilled workers to all branches of society. So I'd like to invite you to check our website. Also, during this General Assembly, we prepare a schedule that includes the following topics: improving scientific writing skills, sharing observations, science diplomacy, mental health management, time management, work-life balance, and public engagement in astronomy, communication, your research to the public. And the specific talks included the following topics: writing a scientific paper, improving writing skills, science diplomacy, the transformative potential of a network of networks to support early career research with astronomy education, engagement, communication, and culture, exploring astronomy as a tool for enhancing mental health, the role of peer mentoring in astronomy. Now that we're going to have this panel of all of the offices, the astronomy, the outreach office, the development office, and also the education office. And finally, we're going to have a talk related with unlocking inclusive outreach, connecting minds to science. So it's a pleasure that we're going to have this panel. So we're going to stay with Chimiso Macwilla, Marcus Posel, Kevin Governor, Geoffrey Maluli, Kelly Blumenthal, and me, that is Camilo Delgado Correal. So I'm going to ask the first question for the panel. So the question is the following. How junior members could be involved in the projects carried on by each office? And also, please give a short overview for each office.
Hello. Oh, wow, that is loud.
Yeah.
Well, hello. My name is Kelly Blumenthal. I'm the director of the Office for Astronomy Outreach. Just to briefly give you an overview of what we do very, very quickly, we have two main avenues of trying to engage with the public in various different ways. One of them is by directly engaging with the public through our projects and programs that we promote through our national outreach coordinators, which are a network of contact points throughout a number of different countries, over 120 countries throughout the world, where we provide them with resources, frameworks, materials, and they go out and bring those resources to their communities. Another way that we try to promote astronomy with the public is by professionalizing astronomy communication. We do this through our Communicating Astronomy with the Public programs, such as our journal and our conference series. And I think the greatest way for junior members or young astronomers to get involved with the OAO is through this process of trying to get people more excited about astronomy as a conduit to being excited about science. And I think that's the power of astronomy, is that it brings people in from a number of different perspectives, whether you have a really strong affinity to science, or if you're really strong in the arts, or somewhere in between. Getting interested in science through astronomy is a really great way to bring as many people in as possible. So getting involved with the outreach office would kind of give you the resources and materials you might need to do something like that. But also, if you're interested in maybe pursuing a career in something related to astronomy communication or education, then being involved with the CAP conferences might be something that you're interested in. And that's something that we can talk about maybe offline or a little bit later. Or if you're interested in the science of science communication, you can take a look at what we offer for CAP Journal and try to publish in CAP Journal as well. It's completely open access, so it's free to publish in and it's free to read, and it's all online, so you have total access to it if you want it. But I think I will pass the mic on to one of my colleagues.
Okay. Okay, so hello, my name is Marcus Bössel. I'm the director of the Office of Astronomy for Education. And you see the slight shift in naming there between OADE, OAE on the one hand and OAO on the other. Astronomy for Education is not the same as astronomy education. So we are interested in ways of using astronomy to further education, to further broader STEM education, to further any kind of education in primary and secondary schools. And of course, one thing that we share with all the offices is that anything the IAU does is, of course, on a very high international level, whereas we all know that the real work is happening at the local level. So if you want to get involved in leveraging astronomy for education, it is very clear that you should look around you. What are the local organizations, local entities, local institutions, maybe your own physics or astronomy department are already doing in this direction, and that should be your primary focus. If you decide that this is something you want to do, if you want to get involved in the education side of education and outreach or in the formal education side, then hopefully we have some resources to support you. So if you want to know about the various aspects of what one should know as an astronomer to be active in education, I would like to invite you to our really online workshop, the Shaw IAU workshop on astronomy for education. It's online, it's virtual, it's free. So look it up on astro4, for is the number, edu.org. I guess we have all the links in the comments or in the program somewhere. And maybe join us this November for this workshop and get to know some of our community. Beyond that, we might have some additional offerings for you. We are in the process of building a fundamental set of astronomy education resources. So we've started with basically a dictionary. We call it the multilingual glossary because we are also very interested in getting translations of educational resources in numerous languages, because we all know that if you are in primary school or secondary school, you don't want to add speaking a foreign language to dealing with astronomy. So everything that is local in terms of materials should be in the local language. So we are always looking for help with translations, with reviews there. Again, take a look at our webpage. And last but certainly not least, if you're interested in being active in your own country, for your own country, have a look. We probably, more probably than not, have a national astronomy education coordinator team in your country. So these were the people you should then contact to see what can you do, what structures are there already. And maybe you find that your country does not have a national astronomy education coordinator yet. In that case, consider applying. We try, just like the other offices, we try to build a powerful and strong network involving all the stakeholders in the different countries. And yeah, I think those are the basic things that you can do with the Office of Astronomy for Education. And before I pass on to Kevin, there he goes again. I'd like to pre-register a question for all of us, and that is, given how little value scientific academia places on this kind of outreach and education engagement, can we even in good conscience ask young astronomers to support us? Because I think that's actually a highly non-trivial question, and I would like to know your answers at some point during this discussion. I mean, not right now, obviously, but all right. Kevin, over to you.
Thanks, Marcus. So I'm Kevin Governor. I'm the director of the Office of Astronomy for Development, the oldest of the offices, so I have the most gray hairs. We don't know what we do. The only thing we know is that we want to make the world a better place. And we do whatever we can to make that happen. And we use astronomy and all the aspects related to astronomy in whatever way we can to make the world a better place. So if junior astronomers want to join us in that, we're super flexible and we always try to be agile in terms of, like, someone comes to us with an idea, we'll try and see how it fits in. Now, obviously, we can't tell our funders that we don't know what exactly we're doing. So the office started off like throwing it out there. We as a global coordinating office may not know exactly what's going on in different parts of the world. So we challenged anyone anywhere in the world to come up with ways that they can use some aspect of astronomy to help their communities, to build their societies. Because when our office was named the Office of Astronomy for Development, the reality is that there's no universal definition of development. There's something close, which is the United Nations Sustainable Development Goals, but there's a lot of flaws in that as well. There's a lot of, it's not straightforward that that should be the final answer. So when the pandemic hit, for example, we didn't like stick to SDGs and stuff. We said, okay, what can we do to help the communities that are affected by the pandemic? And we sort of pivoted our whole activity and ran a separate call just for projects relating to the pandemic. So it's meant to be a sort of flexible office, but what we do is that from all these projects, because anyone can come up with any idea, no matter how wild, we leave it completely open, come up with an idea how to use some aspect of astronomy to impact on society. And then from those, we sort of filtered out the ones that seem to be having the most impact. And that sort of brought us to 3 flagship projects. One is economic development in rural areas through astronomy tourism, using the dark skies that we have in rural areas. The second is dealing with using astronomy to impact positively on mental health. And this is, in partnership with psychologists. Because if you think about it, if you communicate astronomy, you can either say like, we live on this tiny speck in the middle of this massive universe, and like, we're all alone, we're just dust in this big place. If someone suffers from depression and anxiety, you might not want to say it in that way, but you could say that in this massive universe with billions of stars and billions of planets, this is the only place that has life. How special is that? How special are we that we can be on this planet? So the rhetoric can be different, but how do we connect it to mental health? And then the third aspect is looking at data skills and how we use data skills and infrastructure from astronomy to impact on society, and that has emerged in the form of hackathons where we use the cloud computing facilities at the Institute for Data Intensive Astronomy, Data Intensive Astronomy, and run programs that can use that infrastructure and the skills to analyze maybe data that's not in astronomy. So those are flagship projects, like our other sister offices, brother and sister offices, sibling offices. We have a global network. There's project coordinators all around the world, but there's also 11 regional offices. And the principle is that we have the structure. If we come up with a really good, solid plan, for example, the mental health guidelines, we can roll it out to a broader community and let them implement. So for junior astronomers to get involved, there's lots of fellowship. There's fellowship opportunities. We constantly have fellows, volunteers, interns passing through the OAD. I should warn you that once people pass through the OAD, they don't want to leave. And people like that we work with tend to want to work for the OAD. So, what can I say? We have a nice working environment. It's a space where we try to create an interdisciplinary space, a space for creativity, a space where people can sort of find something that they are passionate about and then like we help to shape that into something that will have a significant impact. And we try to go by the principle that there is a minimum threshold. All the work that all our officers are doing, it has to be, we have to get past the threshold. Otherwise, all the work that opposes it, all the hate that's being spread in the world by other forces, all the fake news and the things that are countering our communication of science, our use of science. If we don't like hit a threshold where we can tip the scales, then all our work might be just like scratching the surface below here, while the world is sort of dying in the other sense. So we need to make something big happen, and that's why we look for more fellows, volunteers, and so on.
Hello. Well, first, I am not Siamisu. I am replacing Siamisa. My name is Samantha Brown, and I am a postdoc at the Office of Astronomy for Education. And, well, I think Marcus has already pointed out the main ways in which junior astronomers can get involved with our office. Maybe one thing I can add is that, or expand a little bit on, is that if you have any educational resources that you developed, we are always happy to receive this, either to add them on our website, or you can also submit them to the AstroEDU project, which you can also find on our website. And yeah, these are resources for primary and secondary school education. And yeah, just to remind you to contact your local NAIC to get involved. And I think maybe that's all I can add. Thank you.
Hi, everyone. I'm Joyful Mdluli. I should have actually started instead of making Kelly go first. So I am one of those people who went to the OAD and never left.
See how it happens to you.
So I joined the OAD last year in June, and I'm still with the OAD now a year later. I've just started a postdoc with them. I really can't say more after what Kevin said. I should have really gone first, honestly. Geez. Okay, so what is it like to work for the OAD? It's a very nice office to work for. Whether you are there in person here in Cape Town or you just join in from remote places, it's a very welcoming environment, and you really don't want to leave once you join them. I've spent the past 12 months learning about all of the things that the OED does, and it's quite inspirational. Like the annual call for proposals, you don't actually see how much your science can make a difference until you get active with the OED and see what kind of things you can actually do with your science beyond the research itself. So yeah, if you if you have an idea and you think you want to do it for your community, the annual call is one of the best ways to go about it. But otherwise, if you feel like a proposal is too long, you can always just write an email to the OED and someone will respond. Kevin is when he said that if you reach out, there's a way to slot you in. That is actually very true, because we even have an intern who's a psychology student at the office. And she was interested in astronomy, and she's like, oh, I like the Astronomy for Mental Health project. And she came in, and now we have a psychologist, we have a social worker, we have a particle physicist, so that's me. We just have people from different backgrounds, and the only thing we have in common is the fact that we want to make the world a better place.
Thank you. It's impressive, no? All of the work, all of the office have been done. I'm part of one of the office, so the Orange office. So I understand very well all the tasks that we're doing. So now I have other question. That is, how can be joint force for each office to improve the early career astronomers' professional path?
Can you please repeat the question? Now you're muted.
Oh, sorry. I'm going to repeat the question. Yes, because I was moved. Sorry. How can we join a force for each office to improve the early career astronomer's professional path?
Yeah, that's the difficult question in a way. The other panelists and maybe also some from the audience can tell me if I got this wrong, but from my impression, from the countries I've worked in, I've worked with, it is a sad truth that academic advancement is, of course, tied very narrowly to the research you do, to the articles that you publish. And it's a little bit, there's a little bit of a gap, because departments, institutions, universities, politicians will tell you that it's important for scientists to go out, to go into the public, to initiate a dialogue, to initiate interactions. But sadly, my experience is that there is a type of scientist who is really good at that, who does it very often, very frequently, spends a lot of time on that. And this kind of scientist then tends to sort of move out of science, which might not be a bad thing, but for some, it is not what they had planned, because the scientific career itself is really more focused on, they are not going to look, does he have outreach engagement? Did he contribute to education? Did they do this extra service? But they are going to look at your papers. And we had a little bit of this also in one of the podium discussions. I think Kotze at this time mentioned the problem of, mentioned this as a particular problem of underrepresented minorities, that it was difficult to get them to stay in science because they tended towards outreach and education roles. And I think there are several aspects to this. And one is something that we, most of us in our positions, cannot really change, because it is part of how the system works. I think it would make sense for the whole academic system to move towards a state where it is recognized that science is more than research, more than university teaching, but also involves outreach components of, and I'm not in the narrower sense of the OAO, but sort of including all of what the offices who are here on stage do. I don't think we are there yet, so I think at this point there's sort of two different scenarios. One is that if you are a scientist who plans for an academic career, who plans to stay in science, then you need to find a good balance. For your scientific career, you really need to make sure that you spend enough time, enough effort on your research, because that is what you are going to be judged by, judged on by your peers. For those of you who are coming over, I'm not saying the dark side, but who are coming over to the other side and to say, okay, my engagement with science was what it was a good part of my life, but now I'm moving towards, say, working for one of the offices or working in another capacity, or maybe transitioning to be a science journalist. There tends to be no structured career path to that in my experience. I mean, in science, in most countries, there is a structured career path. There is a vibrant postdoc market. That postdoc market is international. There's a certain seasonality even about when you apply for the new positions. Depending on the countries, there might be intermediate stages before you then apply for faculty positions. I know that in the US, for instance, named fellowships are sort of a common next step and a common next career step. My experience is that in what we do, it is much less structured because in a way it is a much smaller field. Occasionally, opportunities will come up, and more narrowly answering your question, I think attending something like the Shaw IAU workshop, attending something like the professionalization events of the OAE, I think that is definitely a good move, even if you want to stay in science, but more so if you want to transition out at some point. But yes, in the end, I'm afraid that we live in a system where you have to choose, and maybe some of the even younger people at the end of the table who have, I believe, made the decision can tell us about their personal side of it. But yeah, I'm afraid those are the realities. Or am I too cynical? No, just the right amount of cynicism.
No, I think that's fine. I think that the question we need to ask is how how we want to define our own careers. I think in my case, I was on a research path with nuclear physics, and at one point, I was not spending my weekends reading research papers. I was working in communities, and so I made a decision even before I started working or got the job at the observatory. Even before I interviewed at the observatory, I made a decision that I want to do something different, and so I didn't define it by any peer pressure or anything. I defined it by my own choice. And so I let the career shape itself around what I wanted to do. And, I think that's one approach that you can do is find what drives you, find your passion, and then, hope for some good luck along the way. But what got me into this was that those weekends that I was spending doing community stuff was stuff that I was doing for myself, or not for myself, but like the stuff that I was passionate about doing, and that got me noticed. And so when a job came up, I was actually headhunted for it. So yeah, sometimes things work out differently as well. Rather than chasing a career, you chase a passion and the career finds you. But I think you guys are the ones to say more.
Yeah, maybe I can tell a little about my experience. So my background is in astronomy, but after finishing my PhD, I was not sure whether I wanted to continue in academia because of all the structure that we already discussed that is not very compatible with having a work-life balance and, some stability. But I always enjoyed doing outreach and also tutoring and all of these experiences since I was in my bachelor's. So I just decided to approach Marcus and ask if there was any opportunity for me to collaborate with what they do at the House of Astronomy in Heidelberg or at the OAE. And as Kevin mentioned, some luck is needed because I was very lucky that there was actually a position there. And yeah, so this is how I ended up working at the OAE. And even though it was not fully outreach, but more education, I've been learning a lot and I really enjoy it. It's a very fulfilling and rewarding sense that you get when you see one of the projects being completed or people interested in collaborating with each other. It's also been very nice to have the opportunity to meet people from anywhere in the world and get to know the situation, the educational situation in each country. And yeah, see that in the end, we're all looking for the same thing and we just want for our countries to be better, our people to have higher quality of life. And I think that education is the way to do this. So I'm very happy to be in this path. Thank you.
Okay, I really should start volunteering to go first. Yeah, no, I think same for me, same as what Sam just said. But then the difference between me and her is that I knew that I didn't want to stay in academia by the end of my PhD. I was like, not for me, which is weird because I spent a whole 8 years trying to get a PhD and I was like, I'm going to be doing research. And then at the end, I was like, nah, I don't want to do this. But I think this only came up like the last year of my PhD. I stopped doing all of the community engagements that I used to do before that. And by the time I was done with my PhD, I was just absolutely miserable because it turns out that I enjoy talking to people. I enjoy engaging with people, and I like enjoy going out there and sharing the sciences and all of the possibilities that are out there. So it was like when I stopped doing that, I realized that maybe I was doing the science because I enjoyed the fact that I could do all of those things. So yeah, I was at home hanging out thinking, what do I do with myself? Because my whole plan revolved around getting a PhD, then doing a postdoc in research, and then now I just changed completely. And then while I was at home, I came across the OED by some lucky coincidence. I wasn't even out looking for them. They just popped up out of nowhere on LinkedIn. And then I reached out and they were like, sure, we can take you. And then this is how I ended up here at the office. But then, yeah, I think it's good to have both the research and then also something else that sort of kind of helps you take a break from just fully being focused on research. Maybe other people don't see it like that. They just want to focus on one thing. But I feel like it's just nice to have something to do to distract you a little while you organize your thoughts and take a break from the focusing. So yeah, but I also just came across the OED by chance because I was just really, really looking for something that was not research focused because it was really exhausting just doing one thing for me.
Follow-up question for Joyful. When you said that at the end of your PhD you knew that this wasn't for you, was this a question of your own intrinsic experience, or was it a question of being in a space that was not shaped in a way that you were welcome?
It was being in a space that was shaped in a way that I felt like this just didn't work.
I'm so sorry to hear that, and I think that is a systemic flaw that is beyond what we're discussing here, but that is, you shouldn't have had to go through this. I'm sorry.
Thank you for your answers. Let me.
We have a hand in the room and online, so I don't know who's going first.
Okay, thank you.
So yes, one from the room, maybe.
Okay. Can you guys hear me?
Yeah.
I'm only asking these questions for Charles. All right. So I'd like to know, I already know the Office of Astronomy for Development is here in Cape Town. The other offices, where are they based? The one for outreach, the one for education. The next question is there just one main office for each one of you? They're not multiple offices of outreach, education, and development. You understand what I mean? The other one is, are you guys guided by, and I think I heard something like this. Firstly, the first 30 minutes, I couldn't hear anything. I don't know what was wrong with your mics, but people were speaking softly, the first one, the second one, but Marcus, I could hear exactly what you were saying. But are you guys guided by, and I'm asking this because of what you've already said about your offices and what you do, but are you guys looking at those SDG goals and everything, and are your performance agreement guided by those? Because I feel like your work is talking to those more, including, the UN goals, whatever they are. And then the third one, and I'm sorry, is because I'm interested in what you guys are doing, is, yes, I normally see calls from Kevin's office. My question is, do you only rely on these calls to implement your work, or do you guys actually do go to the ground as well to implement your objectives? Or do you only implement your objectives through these calls? And then the last one related to this is, what is a hard no in terms of, the responses that you receive to these calls? For example, if I'm from government, but I've really got a great idea and I feel like your call talks to my heart and I want to apply for it, because I'm from government, would you guys say no to that? So what are your like hard no's where you're like, no, these type of people, or these people from here, or because this one lacks this, what are the hard no's that I should know about? I'm so sorry for the many questions, but I'm interested.
Okay, let me take this on behalf of the officers. So how's this? Can you hear it now? Okay. I wish I had Zolile's voice. If anyone doesn't know that man, go and talk to him afterwards. He has the coolest voice in the world. The big picture of the offices. OAD, development based in Cape Town, global office in Cape Town. It has regional offices around the world. The OAE, based in Germany, at the Haus der Astronomie, but it has centers and nodes across the world. The OAO, based in Japan, and it has national outreach coordinators, but not full offices, but outreach coordinators all around the world. And they're working on offices as well. But the main coordinating points, South Africa, Germany, and Japan for these three offices. About the question specific to the OAD and in terms of the call for proposals and so on, I knew that, if there's a funder in the room, I shouldn't have said this about we don't know what we're doing. But yes, our performance appraisals and our key performance indicators are matched to the Sustainable Development Goals. So we do tie our work to the Sustainable Development Goals because it is the closest we can get to a universal definition of development. And so we in our impact assessments, we look at how many of the Sustainable Development Goals can we have an impact on. For example, mental health relates to Goal 3 on well-being and so on. And so we do tie it to the Sustainable Development Goals, but the openness comes from the open call. And to answer that part of your question, anyone, anywhere in the world is welcome to implement. Remember, the funding for the call comes from the International Astronomical Union, which is a global non-profit organization. And so we can use that independence to sort of allow anyone to apply for a call. The one difficulty that we have, that we are currently experiencing, is how do you send money to countries that are under sanctions, under international sanctions, and that is a sad reality. Is that we would get a proposal from a country that is experiencing international sanctions, and then you try to send money, but your banks say no. We're not allowed to make any bank transfers. So this conference, for example, there were a number of people who were trying to, for example, pay registration fees, but then the country, they're not allowed to send money. And so having virtual participation and sort of hybrid activities and so on helps to a certain extent, but we can't send grants across those borders. We're still trying with the International Science Council and so on to work out how we can do this, but that's our only block. No, thanks very much. And I think that comes to the last part of the question, which is about types of projects. We are really open now. If it means going on the ground and trying out projects and stuff, we do that. We have that flexibility, but we don't do it as a continuous ongoing thing. We do it as like someone came up with a really cool idea to work with, let's say, kids on astronomy for peace. So we did this project once in the schools in Khayelitsha in Cape Town, where we had we did a pilot for how to conduct a randomized control trial of an educational resource on the cheap, and how we did it was we ran an outreach activity on the pale blue dot, Carl Sagan's pale blue dot perspective, and then we had one randomly selected group that took a test before and another group that took a test after, and then you can almost compare it as though it was a sample with two treatments. And so we can do that. We do it as pilots, but we don't do it on an ongoing basis. Okay, stop there.
I will add also to the issue with payments. Another thing that we face as a really big problem is overheads. So some countries, you'll be able to transfer the funds, but there's like a 40% overhead. So the bank will take 40% of whatever you're trying to send. And then, the amount that you're trying to, use to do any kind of outreach activity or development activity is just, completely gone. For us at the OAO, we don't have a call that's open to the public, but all of our national outreach coordinators can work together to put together projects that are funded by the OAO. And the only hard no that we have on those is that NOCs have to work internationally. So these projects are meant to be activities that cross international political, national, cultural borders. So a single NOC cannot apply for this funds. It has to be something that's done jointly with another country.
In the case of the OAE, the call for National Astronomy Education Coordinators is open in principle. It is a voluntary title, and it is open for anyone involved in astronomy education. So this can be a teacher, a professional astronomer, an amateur astronomer, someone who works at a museum, a planetarium, anyone who is somehow involved in astronomy education. At the moment, we have a limit of 5 people per NAIC team per country, and anyone else can become an associate NAIC. All of these decided by the current NAIC team, of course. And another call that we have every year is for the teacher training program. And for this, we face some issues with payments, like Kevin and Kelly have mentioned. And the other limitation for this call is that you have to have a NAIC support your teacher training program in order to apply. But yeah, it is not limited by where you're from or what your background is. You just need an NAIC to support you. And if you want to join us as a translator, or if you want to submit resources, you just need to have the knowledge of the languages you want to translate. If you want to join as a reviewer, then you do need to be either a teacher or an astronomer, just to ensure that the work you're doing is backed by your knowledge. And for the resources, we just ask that it's open access or has a Creative Commons or one of these licenses. But that's all the limitations I can think of. I don't know if I missed anything, Marcus.
Thank you for your answers. There is one from Zach Nitte from Medina online.
Thank you. Can you hear me? Yes. Okay. Well, I think this topic about the payment situation and how to make this kind of activities more professional, as Camilo asked at the beginning, I think I don't agree totally in the speech or the experience that you share, because when you say that there could be like two different paths, like stay in academia and not stay in academia is a choice. I don't know if you see the statistics, but it's not a choice right now. It's a situation that we cannot confront. Camilo showed yesterday how the amounts of positions in academia are lower and lower, and the statistics show like less than 1% of PhD holder achieve a position in academic environments. Let's say not to be a professor and winning a Nobel Prize, just to have a work in academia is really hard. So it's very nice that people choose, that have this privilege, this stability to have a choice in the situation, but actually it's not a choice. And even if you work really, really hard and you want to continue in academia, this path is not as simple as we think, that we can choose to stay or not to stay. So I think it also needs more stability in the younger scientists need more stability. And I know that talking about payment and make voluntary work is always make noise in young researchers. I'm totally agree in all your beliefs and philosophy. We can't contribute a lot in the society. We can do a better work with astronomy. I'm a total believer. I haven't spent my career doing that, and I've been doing a lot of work for free because it's a passion. It's something that you believe. It's not like I want to get paid or I want to get a job in this field. I really believe, but I also love my work in science. I also love to talk about research, to talk about equations, to talk about new discoveries. So it is a situation that younger generation are affronting, and we cannot keep thinking that it's a choice, because it is not. It is a situation, a problem that need a different solution. So, but there are things that the International Astronomical Union can do as a voluntary work. I mean, it is hard not to pay, but many people can do job for voluntary because people believe in it, and maybe the IAU can support them as giving them I don't know, certifications or some value in this support that can help the people in different jobs applications. So this could be something that is not costing and will help a lot the people that is providing this voluntary work. So I wonder if the different organization for education, outreach, and also for development will consider or are really consider that, like giving the voluntaries some recognition that they can show when they leave this work.
So anyone from the panel would like to say something?
Yeah, sure. Just to check, can you guys hear me over in
Yes,
that
we
side
can
room?
hear you.
Okay.
Yeah.
So the thing that the OAO has been thinking about, and actually I have a few thoughts about what Zach just asked, but the thing in particular that I'm thinking of with respect to giving volunteers some kind of credit for the work that they do. I do think that, at least on the OAO side, we do try to give out certificates for everything that people do so that they have that kind of recognition. But certificates aren't really enough because that doesn't really mean anything. You can't put that on a CV and say, you know, I did this activity and I have this sheet of paper from this random name that maybe doesn't mean anything to anybody. So what we really need is some kind of accreditation service within the IAU that or within some affiliated organization that we can go through that says, if you do this activity and you submit this paperwork, then you can be credited as having this expertise in this particular branch of astronomy outreach or education or development. And that is something that I am thinking about, but is a very difficult nut to crack because it's difficult to find out how to accredit something that's as widespread as doing like an outreach event. Like how do you, so there's many different things to think about with that. But another thing that I wanted to mention, you said that it's really not a choice about whether or not you can stay in academia. And that's absolutely true, but it's also true that it's really difficult to find a job in astronomy outreach too. I can't necessarily speak for education or development, but at least in astronomy communication, it's such a niche field that it's maybe not any easier to find a job in astronomy communication than it is to find a job in academia. But the good news is that all of the skills you learn doing astronomy communication can also be transferred into basically anything that you do with your daily life, including research, making sure that you're able to best communicate your work and educate people on your work and write about your work makes you a better communicator, and it makes you a better researcher. So putting some effort into honing your skills in these areas, whether or not you're going through the formal process of working with the offices, but just working on those skills can make you more hireable in the future, whether or not you're looking for an outreach job or you're looking for a research job.
That's why I think a certification or a proof of the participation when people is volunteer in these different the 3 different offices or in the different calls could be added in the certifications, like the skills you got from the training. Because when you apply for jobs, as you say, a certification may not say so much, but it may say like the skills that you have from I don't know, providing educational tools to the Office of Education. So you participate in a call, you make this leadership of a project, and then you got these skills, and then you provide this value to the organization. So maybe it's the way how it can be described for people, right? Because it is important in job application. People cannot talk to you, they don't know you, but they see your CV, they see your certificate. So it helps a little, and it's better not than nothing. So it's very nice that the outreach office is doing that. And if the other office don't do that, I will encourage you to do it, because for job applications, that is very, very valuable. And it can make a difference in getting interviews.
Okay, just to answer that for the Office of Astronomy for Education, basically consider me repeating everything that Kelly said, because we also give out certificates. We do listen to the National Astronomy Education coordinators, and this need for something to show, for some formal token of recognition of their work and of their achievements is something that we know is very dear to a number of them. So of course we are accommodating that. I'm a little bit led. I think the only point where I diverge from Kelly a little bit is I don't think the IAU name is something that nobody has heard of. No, but I mean you're representing the IAU, and sort of even outside the Remember Pluto crowd, I think the IAU is fairly is at least in academic circles is of course a name that is known. I really like your idea of going some direction into an additional accreditation process, although I'm very aware that this would really be difficult and resource intensive, but yes, if we could make that work, that would be really good. Last clarification, because I think you were referring in your question to my description of the either or. When I said that you have to choose where you want to go, I did not mean that you would automatically get success at whatever you choose. And I have to agree with Kelly, is that the choice you can make is which direction you go. But it is very clear that on both sides, both on an academic career and for a career in outreach, there is a scarcity in jobs. There is even more of a scarcity in jobs that are not term limited. And we are very aware of that the people who are sitting in front of you
Roughly.
are roughly, Neil. Okay, we are very well aware that what you're seeing here is a hugely biased data set, right? So we are per definition part of the few people that have gotten where the combination of skills and opportunity was just right to achieve a certain stage. And I'm very aware of the privilege that this means, and very thankful for everybody who made it possible. So.
I know. Hi. I know we are running out of time because there's another session coming up. I have 2 points. The first one would be for you to think about the financial model that you're using for the OAO, for example. I agree that we want to have collaborators between the NOCs to run project. But when you look at the funding that you get and when you want to run your workshop, it's not doable. If I bring 10 NOCs from Africa to train them in South Africa, you give me 2,000 euros, I cannot pay for the flight to come here. I can't train them. So maybe that financial model need to be reviewed on a case-to-case basis. So I want you to think about it. And my second point is, I think I will challenge you because you guys are new. The IAU has been existing since 1919. When we are talking about the NAIC, we are talking about the NAIC of a country. When we are talking about the OAO, we are talking about the NOC of a country. Is it not time for the IAU, and maybe you guys can take it forward, when you're awarding any grant to your NAIC, to your NOC, or even OAD, go it through your consulate, your ambassadors of that country. We are doing that for your country, which is going to be run through your NOC and your NAIC. Start building that relationship with the state, the people of the state. And I think that can facilitate a lot of the problem, the financial and any other problems that you're getting. Because right now it's between you and the people on the ground. The people at the government level, they're not seeing anything. They don't know what NAICs are doing in their country. So maybe I would challenge maybe to find a solution, maybe together, of how we can involve policymakers and you and the IAU so that NAIC, everybody is considered, nationally. Yeah, thank you.
So
I think what is true for all the offices is that we are not ideas limited or creativity limited, we are all budget limited. And in fact, given the amount of money that we have, it's very difficult to come up with ideas that do have impact, that cross the threshold that Kevin was talking about. We are very painfully aware of that. I personally don't think that I would get an ambassador to come out of their office for the $2,000 that we are awarding to a project. I do agree that it's important to build relationships between the NIACs and the education authorities, the education ministries. We are trying to foster this actively, but it is a really hard problem to solve. We do provide letters of introduction. We do try to leverage the name of the IAU when it comes to these issues. In a very few countries, it has actually worked in the sense that we have somehow supported curriculum change, but I would be telling a lie if I said that this was a fundamental OAE achievement. There were always circumstances that made it possible within that country for those individuals to have an impact on, say, the curriculum process. So I think that our power there is very limited, but we're very aware of actually all of the problematic aspects that you raised and very much looking for solutions.
So thank you for your answers. I think that of the information that we have received, we have a great overview of all of the offices. And thank you again with our panelists. So thank you so much. And I don't know if any of you would like to say something as a final remarks or in the panel.
Well, just to say that even though you might see us as different offices and how we described it, the important thing for junior astronomers and everyone to bear in mind is that this is a synergy. It's something we all work closely together. We meet on a regular basis. You'll see when you go down to the exhibition area, we've got all the offices in one exhibition. So we make sure that we sort of synergize everything, and it's clear in terms of like what you're passionate about. If you come to the OAD and we can identify, what your idea will work well with the OAE or the OAO, we all know each other's work and we work together. So feel free to reach out to any of the officers if you'd like to get involved. If you'd like to, and if you're interested in that sort of in a career trajectory that does not involve research, we have lots of cool people who can give you advice in their careers, and hopefully you'll find something cool to work on. Thanks very much.
Okay, thank you again. So now we're going to, So now we're going to move to our final session for today. That is, it's called Unlocking Inclusive Forest, Connecting Minds to Science. So it's Nadim Osir is there. Nadim. Is on the audience or virtually?
I am here. I'm present.
Okay.
Do you have a small slides that I've sent also? That was uploaded yesterday. There's a slide that you're supposed to be having on the screen. Sorry? That was uploaded yesterday, 24 hours before the talk. I can copy it for you if you want. Okay.
Nadir. Nadim, you are going to have your 45 minutes, no? You are going to have your 45 minutes for your talk. I mean, we're going to begin and we're going to have, so we're going to finish around 10, 20, 25, no? Because now is, I mean, we're going to find, you're going to have your 45 minutes.
Yeah, sure, yeah.
Okay.
So if you want to have a small, stretch your legs, by the time we solve the technical issue, we can be back in 3 minutes.
Okay, great.
Okay, it's here. So now we wait for 2 minutes for people to come back from the bathroom. You can do some stretching. Don't forget to breathe. I can teach you the telescope dance if you want in the meantime. Oh, so if you raise your telescope, you've got parabolic dishes. Okay, so when you start your observation, you always look at your amplitude calibrator, which is your flux calibrator. Then you will go into your phase calibrator, you look at your target, and you will scan. At times you will do what we call an RFI scan. So you go low and you do your RFI scan. So we can do that to some music. Great. Eduardo, you can tell me when I can start? Okay, great. So welcome everybody. I'm Nadeem and I'm going to talk to you about unlocking inclusive outreach. I am in IAC, which is a National Astronomy Education Coordinator for Mauritius. I used also to be a NOC, and I work in South Africa, and I've been involved in outreach educations for the past decade. I want to start this session by asking you to close your eyes, all of you. Close your eyes. Now, what is the color of my lanyard? Is it red? If it is red, raise your hand. Is it green? We have one hand. Is it yellow? 4, 5 hands. Thank you. You can open your eyes. What happened is when you walk into an area space, you see things around and your brain starts capturing those information. Some of us, we retain them, but others, they see other things. They see things differently. So I'm going to talk about outreach and how we connect minds to science. But we just saw now that minds, they work differently. Each one of us, we have different aptitude. Some of us can also be colorblind. We can't differentiate between black and red. Some of us have more auditory capabilities rather than visual capabilities. So when we do outreach, we always try to get youngsters to get so fascinated about the science. But what if some of them, they can't, but they are in the crowd? So when I'm talking about outreach, I'm also going to mention the word in-reach that many people don't talk about. Outreach is going outside your organization and telling people what you are doing. In-reach is how did you teach the people who are working in your organization and tell them what they are doing. The lady who makes your coffee, does she know what is a radio telescope? You are going outside and telling everybody about optical astronomy. The person, the driver who drives you, does the person know what you're doing as an astronomer? So when I'm talking about outreach, I'm going to include both outreach and in-reach, and I want you to remember that word, in-reach. One thing that I'm going to do here, I'm not going to talk about outreach. I'm going to share with you some of my decades of experience and also a new topic which is very close to my heart. Whenever we talk about outreach, and I hear lots of youngsters saying, oh, we are doing outreach, we want to promote astronomy, we want to get more astronomers to come, more youngsters to become astronomers. Ask yourself, how many of them will eventually get a job as an astronomer? How many of them will eventually be in academia? I can give you numbers. We have sponsored more than 1,000 of students, masters, PhD in South Africa with a big project. Not 5% of them we have absorbed in our organization. So be careful when you do outreach. You would see there somewhere on the poster, do you want to become an astronomer? Do you want to come and work with us? Don't go and give false thoughts to students. I will rather use this. I'm doing outreach to engage the mind of the youngsters into a scientific thinking. I'm using astronomy to train you to think as a scientist. And these skills that you will get will allow you to work in many areas, not necessarily in astronomy. And this is what we've been doing here in South Africa. You see all those big radio dishes, the big beautiful images from the Meerkat radio telescope. Before we reached that, 20 years back, we had only 5 radio astronomers in South Africa. 5. And today we have many radio astronomers, but not all of them are working with us. So remember that, especially young astronomers, young future outreach people, that you are not selling astronomy to do outreach in astronomy to become an astronomer. No, this is my belief, I'm sharing with you, that's my personal feeling. You are creating scientific minds. Now, we talk about the minds, the scientific minds, but we just found that each one of us, we are different. On top of that, we also have what we call neurodivergent people. A neurodivergent person, they think, they learn, they behave differently. I say it again, a neurodivergent person think, behave, and learn, and they also communicate differently. When you're going out and doing outreach, in that group of young learners, you may have some neurodivergent students or participants. How are you going to deal? How are you going to detect that person? There are lots of subclasses of neurodivergence. Some of you might know about ADHD, autism, dyslexia, but also there's a group which is called the Tourette syndrome, which is not a big disorder, but it can disrupt an activity, an outreach activity. You might have someone who always say, like, when you're speaking, like, oh, yeah. That person can disturb your activity, but that person might have one of the neurodivergent disorder, or he's different or she's different. So bear in mind when you're doing outreach that if you have someone like that, how do you ensure that that person is not left behind? Because this is what we want to do when we are doing outreach. No one is left behind. We also have autistic students, learners, or even adults. Some of them it's clear. We know, they know that they are autistic. But some of them, they don't know. When we're talking about autistic person, there are some of them who are hyperfixated. They really like one topic and are so passionate about it. Like some other autistic students or learners, they're like, oh, I love trains. Oh, I love aeroplane. Some of them like, oh, I love the space rockets. And then you're trying to tell them about the solar system. They are not interested in the solar system. For them, they want to see aliens, or they want to see. So they think differently, but we still want to be able to communicate in a way that we are taking care of their capabilities. This is an image that was shared with me from a 12-year-old Aryan from Tehran. He's autistic. Big outreach event, talking about lots of stuff. He was only fixated on stars. and he wants to draw stars. He wants to know only about stars. So be mindful of those traits of participants you can have. Do you know about dyscalculia? How many of you in this audience know about dyscalculia? Have you heard of dyscalculia? Raise your hand if you have heard of dyscalculia. 1, 2, 3, 4. It's similar to dyslexia. If I ask some of you, okay, what is 1 plus 5? It's 6. Great. But some participants, they have this disability because when they see equations, everything is messed up in the brain. When you're doing outreach, you want to teach them, oh, you know, there's this equation that we use. At times we do at some level, so in some calculation, they get scared and they will run away from it. So, for example, a dyscalculia participant, if you notice that someone's scared of equation, what is 5 plus 5? They remember those symbols. These, they are not scared of it. Oh, there's 1, 2, 3, 4, 5. Then there's another 1, 2, 3, 4, 5. So 10 is 5 plus 5. But if you ask them what is 5 plus 5, they will not be able to answer you. And now they also found like, oh, there's something called 4, which is 5, and then you subtract that thing. So be mindful of all those traits. And the best way is always to get your participants, your learners, involve them and getting everybody to play. This is one of the activities that many of you have done, where you have all the participants lining up, and then every time they hear a sound, they make one step, and then one step. Every time they hear a sound, they make one step. And in the end, they make a spiral galaxy. And when you show them the photos, when you take the aerial photo, they're like, no, I make only one step. How can I create? We started in a line. I made one step. How can I create a spiral galaxy? So that's where you want to get them to be involved and play. You don't only need to do like, I know lots of us, we use lots of techniques and tools, and especially in Africa, we don't have all those tools, but we can make use of whatever we have for doing outreach. Outreach is also about creating a safe space. I put that picture here of this boy because I was doing an outreach activity and he was sitting outside the school. I tell him, why you're not going inside to do the outreach? The teacher is there. I'm not going, I'm scared of the teacher. He did not want to get into the classroom because the teacher was there, but I was there to do outreach. Then I tell him, like, why don't you help me to carry the boxes? And then when you're done carrying the boxes, you can go home. So he came, started carrying the boxes, and while carrying the boxes in and out, he started seeing what others were learning. And he sat there next to me. And in the end, he participated in it. So remember, you want to create a safe space for your learners. Like there was a talk this morning from Iran, where they're creating that safe space for women to be able to go out and do astronomy, look into optical telescope. We can take it for granted, but in some places this is not safe. So create a safe space for your learners. And also remember your audience. We always say when you do outreach, you have a diverse audience. Know your audience before you go and do outreach. We knew one audience that we were going to do outreach in a small village up in the Northern Cape. When we reached there, the parents, it was school holidays, the parents, the whole village were there. So now we were trying to do outreach with secondary school students. Now we have the parents and we have babies, 2-year-old, 3-year-old, they were all there. You cannot tell them like, no, we are not here to do outreach, okay, with you. No, improvise. Get your students, get your learners, always have lots of materials with you so that you get everybody involved. And outreach is not only about communication. We have the verbal, outreach is about communication, but we also have beyond the verbal communication, we have the non-verbal communication. Here, this is an outreach event where we are having graduate students. They have 3 ropes tied to a bucket that contain water, and they need to move that water to another bucket, and they cannot talk, and they need to move that thing. How do you communicate? How do you get that water to move around? So there are lots of beautiful activities that you can use for non-verbal communication. And this one was the most challenging for me. We organized a education in Mauritius, where we had 10 teachers who are blind and 10 teachers who work with the mainstream students. We put all of them together in one classroom. I cannot use slides to tell them what I'm going to do. I cannot say, oh, visualize I have a sphere. They don't know what is a sphere. I will challenge you, if you want to know how good or how great it is to do outreach, go and do outreach with visually impaired, or even with people who have other impairment. Then you realize, like, wow, outreach is not that easy, but it is so fun where you are able to communicate and bring them together. They created an activity together where now this activity can be used for anybody, whether you're visually impaired or not. We have a small activity that gives you a measurement of scale. And remember, science is for all. And this is what we are here to talk about, astronomy for all. But I would say science is for all, and astronomy is a tool that allows us to promote that science for all. And I will end here to remind you that whenever you go and do outreach, you need to work now with psychologists, with occupational therapists. Learn about all those neurodivergent participants that you can get. You can have also neurodivergent students. How are you going to deal with them? So be mindful with that. And I would maybe again send it to the OAE, OAO, and OAD. It's time for us to start creating training workshops for the NOCs, the NIAC, but including psychologists and occupational therapists to train the NOCs and the NIAC. I'm not a psychologist, I'm not a trained occupational therapist, but I think training them so that they can go, and if they have neurodivergent participants, they will be able to know how to deal with it. Thank you.
There are questions?
Yes.
Thank you for the wonderful presentation. I don't know if it's on. Can you hear me? Okay, cool. I just wanted to find out, is there almost like a standardized outreach activity that you can do that just caters to all of those people? Because I mean, when you leave in home to go do outreach, you're not quite sure what you're going to come across. So is there something that is more standardized for all audiences, or do you just have to pack for all possible situations and scenarios?
You always pack more than what you need. That's what I always do. Yeah, always pack more than what you need. You don't know what you will hit on. Because, I don't know, maybe when we started that experiment in Mauritius, we are going to run another teacher training. When we started to bring the teachers who are blind and the teachers from the mainstream, now we're starting getting one activity which is standardized, but we still need to test it. And I think that would be great for NOCs and NIACs to work together to come with these type of activities that, okay, it's going to work. But yeah, the answer is no.
Okay, and then I just have one last comment. So the SAO normally has these open nights that they have the public coming in, and then you have a scientist talk about their research, and they do a tour of it. So recently I did one of those open nights, except I had a community of deaf people, and I had a translator. That was the hardest thing I ever had to do, because I had to dumb down everything so that the translator is able to actually translate to the people. And since then, I've started appreciating outreach even more, because I was just like, I didn't realize how difficult it was to communicate my science until it had to be for a different audience that wasn't actually fully aware of all of these very heavy scientific terms that we tend to use when we do an outreach that can't easily be translated to other ways. And
yeah, that's one of the reasons on the Slack I was looking for someone who does sign language, because I wanted to have someone to be a translator here, because we talk about inclusivity. I wanted to do that slide, that presentation, by blinding all of you and say like, okay, now I'm going to talk about outreach, you know, and inclusivity. We talk inclusivity, but it's big, it's huge. So yeah, it's hard, but yeah, it's good. Well done. And if you know someone who can speak South African Sign Language, I'll be happy to include them in my activities also. Great, thank you.
Thanks for your presentation. I enjoyed it a lot. Actually, I have a question that I teach in a school where I have one autism student, and the thing is that I don't know if it's good that I mean, should we separate them or not? They have to be with other students because, you know, they understand it in a different way. So I have some struggling to connect with him. Do you
Yeah,
have any suggestion?
I mean, for me, the first thing I ask the participant, I try to talk to them and understand them, and then I will ask them the question. I have a student recently, I'm teaching at university, and he said like, sir, I cannot come to class because I have anxiety. Then I was like, okay, I'm not going to penalize you because you have anxiety and you want to do an astronomy course. So I put my course online, and he's online, he's submitting all his assignment. We have a one-to-one private discussion. But yeah, ask the students, otherwise the participant or the student you have. Otherwise, if you have that's why I'm saying, now when we're doing outreach, get someone with psychology background, someone, you know, who can help you to understand them and get them involved. Because very often, as I said, in the past, we have been doing outreach. No way I've seen a psychologist who has come and do outreach in astronomy.
Actually, I was afraid if, you know, he feel a little bit bad if when I separate him.
No,
And
you don't separate. You always ask the question, and then you can also ask the parents, the accompanying parents. But if they want to be separated, it's fine. You give them the space. That's what I said. Create a safe space for them.
thank you so much.
There are some questions for virtually or comments.
I just wanted to make a comment that I think maybe it will also be important that before you go on an outreach, you try and understand the background of the people that you are going to be talking to, you know, so that at least you show them that you know, you really did your homework, you really care, you know.
Yeah.
One experience that I had that I found very remarkable, there's this blind astronomer from Puerto Rico, Wanda Diaz. We went to some school in Cape Town, and she's blind. She teaches astronomy, you know, using touch, using feel. You know, we went to a school for blind children, and it was amazing to see how they're learning by touching, you know. Very amazing. Thank you.
Yeah. You can ask them question if you know, for example, in which category you're going. But if you're going to a general public, like we have some, I know some people, okay, who are colorblind, and when you're doing like scientific plots, you're putting red and green. For them, they don't differentiate it. And for them also, they might not know that it's red and green because for them it's just two lines. So yeah, it is, one thing you would do is find out about your groups that you want to do, your outreach and education. Otherwise, also keep it at the back of your mind that there is someone who may have some issues and you have to deal with it. Yeah.
I think from virtual, Isaac, would you like to your question?
If it's possible, is it time for? Is enough time for a question? Okay. Okay. Thank you for the wonderful talk. It's very interesting to see this topic. That is. Oh, I don't see the speaker. I only see myself.
Yes, I can see you.
Now you can see me. Okay. Can you see me?
Yes, we can see you.
Okay. Hi, I'm Zach. I'm working in Germany, and my question is, if you, well, I would like to share with you a very short personal story, and then my question. So, this topic of think about or have the sensitivity to thinking your audience is very important. I discovered that I am in the spectrum of neurodivergence people very, very recently, and a couple of years ago. But when I was younger, I worked as a teacher because I need to pay my studies in my bachelor degree. So I did teaching in physics and mathematics. And I always have this feeling that the students were different. So I always treat them differently. I make different exams. I make different exercise according to their skills and how I notice they react. So I was the only teacher doing that, and well, it required a lot of effort, of course. But I always was aware of that. Like maybe people is different, you know, it's something obvious, but not everyone is aware. And now I understand why I was always aware, because I was part of the spectrum. And this give you a kind of sensitivity. And I wonder if you are planning, the group or your institute are planning to maybe do trainings for communicators, because I'm working in Europe, but I am from Latin America. So I always do outreach for minorities. And when I'm trying to address people that are working in outreach offices, that they have the power to support this kind of project, they say no, because we only support projects for our nationals, for the people that speak our language, for the people that is medium class, people that can have an educational background. And they don't have this sensitivity. So I think it's something important for everyone doing outreach. Always consider that and always have the sensitivity of your audience, and try to support all kind of projects that try to go to different targets group, not only the typical well-educated family that want to have fun or or want to learn something new this afternoon, that also consider other groups. So it would be important to increase the sensitivity in researchers in this topic. So I wonder if you would like to increment that, if you have a plan, or if the institution would like to participate with other organizations to do this sensitivity training for communicators.
Thank you, Zach. And as you mentioned, you detected you were under the spectrum recently, and also recently discovered that my wife is under the spectrum. So that's where now I'm having this new way of looking at things and communicating things. And as you rightly say, it's not easy. And on top of that, what we've been seeing based on medical papers and science publication, one of the effects of COVID is a 44% increase in autism anxiety among teenagers. It's a big number, which means that we will have to deal with the students. I'm willing to learn from you, and I will be happy. I see that Eduardo is here, so maybe we can twist his arm, and I'll be very happy to put a proposal so that we can work on something together with OAE. You know, I'm happy because as I said, I'm learning. I got some psychologists that I want to get on board, because we want to build something to train the communicators. Yeah, I'll remember, and I will contact you, Zach.
Thank you very much. Yeah, it would be very nice.
Pleasure.
Thank you.
So there are more questions, comments? I have one that is related with, I mean, you have been working with blind people, no? How was this experience by doing our astronomy with them?
Yes, so if I understood your question, so yeah, I was doing some education with blind teachers, and we had the tactile planets that we got from Wanda Diaz, and we also had the astronomy book, which was written in English and Braille, and we used this with the teachers. And now we also found that there are some other groups in Ghana where they are using some local, whatever they have locally, to make constellation using a calabash and beads. So yeah, we are working on creating some low-cost outreach material for blind people, and hopefully we will put them and share that with you all. Yeah. And I think, okay, there's also another thing that I found this, recently is that you can use painting, like art, like 3D, not 3D painting, but like painting with textures that you can get, like work with artists to create those paintings, and then blind people can learn what you want to represent from those paintings, like a topology of a country, mountain, clouds. You can do that with painting now. So there are lots of resources, and yeah, I'm looking forward to put everything into one place that is accessible.
There is this CAP journal that maybe you can join all of your efforts and publish something, no? The Communication Astronomy with the Public Journal. I don't know if you know about it.
The CAP journal, yes.
The CAP journal. So
yeah.
I think maybe you can, join all of these experiences and publish in this journal. I think it's very interesting. So thank you again, Nadim. It's a pleasure to know you.
Thank you.
With the talk, we're finishing. With this talk, we're finishing our sessions, the junior members working group. So thank you so much for attending our talks, and see you around it. Bye-bye.
Usiswa. Kale wala. Ventene ya sulu.